best pair count is the summation of the sigma and the lone pairs. If that is 2, the hybridization is SP, right? And it is 3, SP2, ඔහොම ගන්න පුළුවන්. හරි 4යි නම් SP3 like that. Right? ඒක නිසා මේ hybridization එක ගන්න කෙලින් පුළුවන් හරි without this thing. Without the right energy level diagram, still you can find out the hybridization, right? Just count the sigmoids and lone pairs. This is the simplest way of finding the hybridization, right? By just looking at the Lewis structure. දැන් මේකෙත් පුළුවන් ඔයාලට පේන්නේ ඒකනේ. නේද? 4 නම් count එක sp3 hybridization එක. right? ඉතින් ඔය knowledge එකත් එක්ක තියාගෙන අපි බලමු මේ කොහොමද handle කරන්න කියලා. ඔයාගේ NH3 කියන engineering diagram එක. NH3. Let's try to copy the diagram of NH3. Right? Involving station for NH3 molecule. මුලින්ම ළමයි කරන්න ඕනේ මොකද්ද? මුලින්ම කරන්න ඕනේ first draw the Lewis structure. හරි? දැන් විභාගය අඳින්න කිව්ව කියන්න. Any diagram involving hybridization for NH3. First draw the Lewis structure. පුළුවන් shape එකම දාගන්න. First draw the Lewis structure with the shape. හරි? ඊට පස්සේ මම පොඩි දෙයක් කියන්නම් තව. ඊට පස්සේ මෙයාගේ hybridization එක මුලින්ම හිතාගෙන ඉන්න. lazy වාට. Two p3, right? Page number 24, right? That question. But let's do a question related to the shapes of the molecules, the orbital overlaps, and the bond angles, as well as some of the electronegativistic things, right? Let's do the question number 1, part B, at the page number 24, right? Page number 24 වල තියෙන ළමයි B වල Roman number 4 අපි කරමුද? අපිට මේ question එක කරන ගමන් ඒ theories ටික මතක් කරගමු, right? Now we are up to the Vesper theory, right? The shape of the molecules and the bond angles and the orbital overlaps and those stuff, right? So just do the 2021 question, part B, Roman number 4, that table thing, right? Such kind of question is always there. 2021 so 21 question number 1 part B Roman number 4. Just quickly complete this question. Roman number 4, 5, right? 6, 7, and 8. Just do all the stuff, right? 5, 6, 7, and 8 until that year 20 stuff. අර එක ළමයි මේ 6 7 8 වලට වැදිලා තියෙන්නේ 1 2 3 කියලා ඉස්සරහට ටික හදා ගන්න right orbital overlaps වල 5 bond එක හැදෙන එකට 6 කියලා දා ගන්න ඊට පස්සේ 7 ඊට පස්සේ 8 right equations එක බලන්න regarding this structure. So 1 2 3 things are also there. 1 Right. Let's discuss stuff. බලමුද? කතා කරමුද? Right? හරි. So this is regarding the Vespa theory and the hybridization stuff, right? Hybridization and the orbital overlap. Those two notes, right? The theory of this discussion is there at the page number 11, sorry, 12 and 13. Hybridization, orbital overlap and the shape of molecules, right? Regarding that, we are doing all of this stuff, right? Right. Topic number 12 and 13. Right? හරි බලමු එහෙනම් කොහොමද මේ question එක approach කරන්නේ හැමදාම මේ question එක අහනවනේ. හරි. Okay. Right. First thing, how to come up with the Vespa pairs, electron pair geometry and the hybridization. That is the first consideration, right? So those things are there at the hybridization and the orbital overlap. That note. Vespa pairs, electron pair geometry and the hybridization. Those things are with a kind of a relationship between them. Right. First thing, how to come up with the Vespa pairs. Yes, what we need to do is, actually we have to count the sigma bonds and the lone pairs around the considering atom. That is how the Vespa pairs, right, that number is gained, right? So for N1, let's count the numbers. The first bond is sigma. Between two atoms, the first bond is sigma, the second is 5, right? Around N1, you have two sigma bonds and one lone pair. Two sigma bonds and one lone pair, right? That count is equal to 3. The summation of sigma bonds and lone pairs is equal to 3. So Vespa pairs is equal to 3 for the N1, right? Okay, Vespa pairs is equal to 3. So what about the electron pair geometry? If the Vespa count is free, always the electron pair geometry is trigonal planar, right? That thing is there at your hybridization node, the third box, right? If the Vespa count is 3, always the electron pair geometry is trigonal planar. If the Vespa count is 4, the electron pair geometry is tetrahedral, right? If the Vespa count is 2, the electron pair geometry is linear. That is understood, right? So electron pair geometry here is, right, trigonal planar. For the Vespa count 3. What about the hybridization? If the Vespa count is 3, the hybridization is sp2. 3 units, no? 1 SN, 2 Ps. If the Vespa count is 2, the hybridization is P. If the Vespa count is 4, the hybridization is sp3. Right? Okay. Let's do the for this one as well. C2. Because C2, you have 1, 2, 3 sigma bonds and no lone pairs. The summation is just 3. 3 Vespa pairs means your electron pair geometry is trigonal planar and hybridization is sp2. 3 units, 1 SN, 2 of Ps. For this one, C3. So first bond is sigma, the other bonds are 5 among 2 atoms. So altogether only 2 sigma bonds, no lone pairs. The summation is 2, sigma plus lone, the summation is 2. So the electron pair geometry, when the Vespa count is 2, is linear and the hybridization is sp. 2 units, 1 SN, 1 P. Right? What about this thing? Right? So this is also sigma. The type of bond between two atoms, right? The first bond is always sigma, right? 2 sigma bonds and no lone pairs with this one. So the Vespa count is 2. The summation of sigma plus lone is 2 for this nitrogen, right? So Vespa count is 2. That means you are with linear electron pair geometry. So that is sp for hybridization, right? Dekai and sp, right? The Vespa count, electron pair geometry and the hybridization, right? All are with a relationship. According to the Vespa count, the EPG and the hybridization is decided. According to the Vespa count, the entropy geometry and the hybridization is decided. Right? Right. So then the shapes around atom. Right? Shapes around atom is decided by the Vespa theory. Right? Valential electron pair repulsion theory. Right? So according to the kind of Vespa pairs, the sigma bonds and the lone pairs, the shape will be decided. Right? When it comes to 3 Vespa pair situation, right? What are the shapes available? Right? You can look at those tables given at the page number, which one? At the page number 13, right? You have the shapes there. I'll quickly go through the shapes before filling the table, right? If you are with Vespa count 2, let's start with that. If you are with Vespa count 2, if all the bonds are sigma bonds and no lone pairs appear, what is the shape? That is linear, right? That is linear. If the Vespa count is free like this, if the Vespa count is free, all the 3 things could be sigma bonds, then the shape is trigonal planar, right? If with Vespa count 3, 2 sigma bonds and 1 lone pair appears, your shape is angular or bent, right? When it comes to Vespa count 4, Vespa pairs 4 situation, if all the 4 pairs are sigma bonds, the shape is tetrahedral. If you are with 3 sigma bonds and 1 lone pair, it is trigonal pyramidal or just pyramidal. If you are with 2 bonds and 2 lone pairs, that is bent or the angular, right? Then, what about the situation with 5 Vespa pairs? If all the 5 Vespa pairs are sigma bonds, the shape is trigonal bipyramidal. If you are with 5 Vespa pairs with 4 sigma bonds and 1 lone pair, its shape is seesaw, right? Then, if you are with 3 sigma bonds and 2 Vespa pairs, right? 3 sigma bonds and 2 lone pairs with Vespa pair 5 situation, that is T-shaped. That is T-shaped, the shapes, right? With 6 Vespa pairs, if all the 6 pairs are sigma bonds, you are coming up with octahedral shape, and 5 sigma bonds and 1 lone pair gives you square pyramidal shape, and if you are with 4 sigma bonds and 2 lone pairs with the Vespa count, right, 6, the shape is what? Square plane, right? 6 sigma bonds and octahedral, 6 sigma bonds and 1 lone pair and square pyramidal, 4 sigma bonds and 2 lone pairs na square plane, right? Those are the shapes according to the Vespa theory. Let's apply those things. So you have a 3 Vespa pair situation where 2 sigma bonds and 1 lone pair appearing. The shape is bent or angular or bent. With this one, C2, 3 sigma bonds and no lone pairs. Lamai, when you are not with any lone pairs around you, your electron pair geometry and the shape both are the same. Hondara balanne examples wala, right? At the page number 13 you can see, if you are with no lone pairs around your atom, your electron pair geometry and the shape both are the same, right? No lone pairs by the end. So the trigonal planar is the shape. So again, linear electron pair geometry, but no lone pairs there. So shape should also come up as linear. හරි ඔයාගේ atom එක වටේට ළමයි lone pairs නැත්තම් ඔයාගේ shape එක heterogeneous geometry එකයි සමානයි. So with this one again, two sigma bonds and no lone pair situation, your shape should be equal to its heterogeneous geometry, that is linear. Right? හරි ඉතින් ඔහොම තමයි table එක fill වෙන්නේ. Right? ඉතින් මේක හැමදාම අහන කතාවක්. Right? What about the orbital overlaps now? Now we are leading to orbital overlaps. Right? Orbital overlaps. So here with the orbital overlaps, what we should know, the major things you should know is when it comes to orbital overlaps. First, for the sigma bond. For sigma bond, what we should know? Orbital overlaps of sigma bonds. Right? Orbital overlaps of sigma bonds. How it appears. Right? Actually, with Lewis structures, there are two kinds of atoms available. Lewis structures, we have two kinds of atoms. Central atoms, like this, where the atom is connected to more than one atom, central atoms. And then you have terminal atoms, where the constituting atom is connected to only one single atom, right? Central atoms and terminal atoms, right? So when it comes to central atoms, right? For the sigma bond, always the hybrid orbitals are involved. I'll just write SPX, the hybrid orbital. The hybrid orbital of central atoms are always involved when forming the sigma bond, the orbital overlap of sigma bond. When it comes to terminal atoms, for the sigma bond, right? For the sigma bond, right? The atomic orbitals are involved. NS, NPO, ND, the atomic orbitals are involved. Right? Here, this represents the subshell with actually that is the ultimate subshell filled with electrons. Ultimate subshell of the atom filled with electrons, right? Final subshell with electrons. That is how we are supposed to write the orbital overlaps of the sigma bonds. Let's complete this stuff then with the use of this theory. Right? Okay. Let's consider N1 and F. N1 and F. N1 is a central atom. N1 is a central atom. What is the hybridization of that thing? Hybridization is 1, 2, 3 units, sp2. So from a central atom, the hybrid orbital should involve. F is a terminal atom. From the terminal atom, which orbital? For the sigma bond. Right? Orbital from its final subshell. What is the final subshell of fluorine? Fluorine is coming up with helium 2s2 2p5, right? So final subshell is this 2p. So fluorine's 2p will linearly overlap with nitrogen's sp2 for sigma bond. With the terminal atoms, the final subshell. With the central atoms, hybrid orbital, hybridization, right? So N1, the sigma bond, sp2 and 2p, right? Okay. Again this one, N1 and C2. N1, another central atom. Sorry, N1 is a central atom, so sp2. C2 is again a central atom. So its hybridization is 1, 2, 3, it is sp2. So from both the N1 and C2, the sp2 hybrid orbitals are involved. Because both are central atoms, hybrid orbitals should be involved in forming sigma bonds. central atoms, hybrid orbitals. C2 and H. C2 is considered as a central atom, but the H is kind of a terminal atom, connected to only one bond, terminal atom. So with terminal atoms, the subshell with the ultimate subshell with electrons. The hydrogen configuration is 1:2, 1:1. So ultimate subshell with electrons is 1:, right? So 1 is from the hydrogen, while the carbon's hybridization sp2. C3 and N4. C3 again is a central atom, so coming up with its hybridization. So 2 sp, that means sp. N4 again a central atom, so the hybridization is sp. So sp and sp linearly overlap to form sigma bond. N4 and oxygen. N4 again a central atom, so its hybrid orbital will involve, and oxygen a terminal atom, so its final subshell. So oxygen coming up with helium 2s2 2p4, its final subshell is this thing, so 2p is the final subshell, right? 2p and this guy is hybrid orbital, that is sp. That is how we are supposed to form the sigma bonds, right? Let's quickly discuss about the formation of 5 bonds. Formation of 5 bonds. So when it comes to 5 bonds, right? It comes to 5 bonds. It comes to 5 bonds. From all the atoms, only the NP or ND orbitals can involve. 5 bond means lateral overlaps, sorry, partial overlaps, right? So partial overlaps. So they are, right, only the P and D orbitals, unhybrid P and D orbitals can involve in 5 bonding, right? You can't form 5 bonding with sigma bonds or the hybrid orbitals. Only the P and D orbitals are involved in 5 bonds. Overlaps to form the 5 bonds. Right? From all the atoms, NP or ND orbitals are involved. So ND is very special. NP, ND represents the final subshell, right? With electrons, right? Okay, ND is very special. ND happens only when not enough NP orbitals remain to form 5 bonds after the hybridization. Right? Say if your hybridization is sp3, if your atom's hybridization is sp3 and it forms a 5 bond, think of such a situation, right? Such situation appear like this. Think of this situation, right? So you have phosphorus PO4 3-. Some example, right? PO4 3-. So I am looking for the phosphorus orbital involving in this 5 bond making, right? In the situation, you clearly see the phosphorus hybridization is what? sp3. This guy's hybridization is sp3, right? sp3. The hybridization of this thing is sp3. This means all the 3p orbitals of phosphorus has involved in hybridization. This guy's hybridization is sp3. That means all the 3p orbitals of phosphorus are involved in its hybridization. So there is no p orbitals remaining to form the 5 bond. All the 3p orbitals are involved in hybridization. So there is no 3p orbital remaining to form the 5 bond. So that you have to come up with ND, the 3D. Right? That is the idea there. So in this case, the 5 bond is made by phosphorus 3D orbital. Empty 3D orbitals are there, right? Those are involved in forming the hybridization, forming the 5 bond, right? No, that is the idea, right? So let's consider this stuff and come up with the answers here, right? Anyway, the ND thing appears with only the third row above atoms. D orbitals appear only with the atoms with the third row above, right? With the second row atoms, you don't have D orbitals, no? With the second row atoms, you don't have D orbitals. So this situation appears only with the atoms, right? With third row above, right? Again, මේක ඉන්නේ තමයි සාමාන්‍යයෙන් carbon nitrogen oxygen වලට එන්නේ. මොකද 3D කියලා ගන්නෑ. Carbon nitrogen oxygen. Second row එකේ second energy level එකේ D orbitals නැහැ. මේ situation එක එන්නේ ඉතින් අර third row above atoms වල phosphorus, sulfur, chlorine වගේ කට්ටියට, bromine, iodine වගේ කට්ටියට එන්න පුළුවන්. Right? හැබැයි ඔය second row atoms ලං ඉන්නේ ආයි හිතෙන්න දෙයක් නැහැ. Definitely that would be 2p. If you are dealing with second row atoms, nothing to consider, definitely it should be 2p. Because second row එකේ තියෙන්නේ p orbitals, s orbitals විතරයි. හරි? S orbitals can't form 5 bonds. Only the available stuff are 2p's. ඉතින් මේක හිතා හිතින් දෙයක් නැහැ. කෙලින්ම 2p කියලා ලියාගෙන යන්න බලුවා. අර පොඩ්ඩක් third row වගේ කෙනෙක් එනවා නම් තමයි පොඩ්ඩක් consider කරන්න වෙන්නේ 3p ද 3d ද කියලා. 3p ද 3d කියලා consider කරන්න වෙන්නේ third row වගේ කෙනෙක් එනවනම් phosphorus, sulfur, chlorine වගේ කෙනෙක් එනවා. second row කට්ටියන එන්නේ බය වෙන්න දෙන්නේ කෙලින්ම 2p කියලා දාන්න ඉවරයි. හරි. ඉතින් ඔක තමයි ඒ කතාව. හරිද? hybridization orbital overlaps. Finally, we are going to discuss about the right bond angles. Bond angles ටික කතා කරමු. Bond angles. Right, bond angles. How to comment on the bond angles? Right. First thing, so they are asking about the bond angles of these stuff, ne? Right. Bond angles ටික අහන්න. අතර වෙනවා. Sorry. Well, hard. Bond angles around these atoms, nitrogen, carbon, carbon and nitrogen. Right, bond angles. Right. What are the theoretical part we should know about the bond angles? Right. So basically, first thing is you should know about the main angles. First thing is you should know about the main angles. Means the angle related to the electron pair geometry, angle related to the best pairs, or angle related to the hybridization. That should be known. That is known as the main angle. So if you are with two best pairs, the main angle is 180. If you are with three best pairs, main angle is 120. If you are with four best pairs, the main angle is 109. For the five best pairs, you have two main angles, 90 degrees and 120. For the six best pair situation, it is 90 degrees. You should know the main angle first of all. Basically, for the best pairs count 2, 3, 4, you should know for these kind of questions, right? After knowing that, what we need to do to come up with the correct angle is actually you have to subtract 2 units per lone pair. From the main angle, from the basic angle, you have to subtract 2 units per lone pair, to come up with the correct angle around the considering atom. Right? So that is the idea. Right? Let's do the stuff for these guys. Right? So here, this is a situation with 3 West units. Situation with 3 West units. 3 West units means, right? What is the main angle? 120. 120. Main angle is 120. But you have one lone pair. So have to subtract 2 units. 120 minus 2, that is 180. Around N1. Right? The main angle, 3 West units, that is 120. 3 West units 120. And no lone pairs. 120 minus 0, that is 120. Right? You have to just write the correct value, right? Definite value. You have to write a definite value. Don't write this one as less than 120. That is false. Huh? If you have written as less than 120, that is false. Because even the 90 degrees is less than 120. Right? You have to write a definite value. So for this one, 2 West units. 2 West units is means 180. 180. And you don't have lone pairs. So 180 minus 0. Just 180. Around C3. This is also 2 West pairs. That means no lone pairs available. So 180. So what we need to do is actually to come up with the main come up with the correct angle is actually first take the bond angle related to the electron geometry or the Western number and deduct 2 units per lone pair. Right? That is what you need to do. Right? So like that you can come up with the bond angles. Right? No? Okay. So those are the numbers for the for the N1, C2, C3, and N4. Right? No? Right. Final stuff. Final thing. Right? It's actually electronity variation for these 4 guys. Right? If you are referring to electronity variation, right, what are the things matters? What are the things matter here? So we are looking for the increasing mode of electronity. Of these 4 guys, right? That is Roman number 8, no? Increasing mode. So what are the major considerations here? So electronity is the ability to attract the electron pair in a covalent bond towards your considering atom. That is electronity. Ability to attract the electron pair in a covalent bond towards your considering atom. That is electronity. If you are with a great ability to attract the electron pair, your electronity is high. If you are with a lesser ability, electronity is low. That is the idea. So in this kind of question, how to handle that stuff? First concern about the Pauling scale. Right? So according to Pauling scale, first we locate these elements. Right? We know according to Pauling scale, all the nitrogens are with greater electronity values than carbons. All the nitrogens are with greater electronity values than carbons. Right? Normally with the Pauling scale, carbon carries 2.5 and nitrogen carries 3.0. So all the carbons should have a lower value like this than the nitrogens. That is the first consideration, right? The Pauling scale values. So if the Pauling scale values are equal, like in these 2 carbons, the Pauling scale value with both it is 2.5. With these 2 nitrogens, Pauling scale value both coming up with 3.0. When the 2 Pauling scale values are equal, then we have to think of the chemical environment. We have to think of the chemical environment. According to chemical environment, those 4 factors, the utility will differ. What are the 4 factors affecting the utility? I'll quickly go through the 4 factors, right? So first thing is hybridization. First thing is hybridization, right? All those things are there in your note, Lamai, in your short note. What is that page? The note number 10. The note number 10. You have these 4 factors, right? At the page number 10. You can see those, right? The first factor affecting the electricity is the hybridization. Hybridization of the atom. Greater the S character of the hybridization, greater will be your utility. That means if you are with a sp hybrid orbital, if you are with sp hybridization, your utility is higher than the sp2 hybridization, which is higher than the sp3 hybridization. Greater the S character, greater will be your utility. If the S character is same, if your 2 constituent stuff are with the same hybridization, if the hybridization is same, the S character is same, then you have to look for the charge on the atom. You have to look for the charge on the atom, right? When the positive charge is high, your utility is high. When the positive charge is high, your utility is high. If the charge on the atom is also the same, you have to look for oxygen state. Oxygen state. Greater the positive nature of the oxygen state, your utility will be high, right? If all of those 3 factors are same, then you have to look for the connected atoms, bonded atoms, right? If some greater utility atoms are bonded to your considering atom, your considering atom's utility will be high. Utility is also referred to as a measure of electron deficiency. That is why greater the charge, greater will be the utility. That means greater charge means you are more than electron deficient, right? Greater charge means, greater positive charge means more of electrons have been released from your atom, right? That means you are electron deficient, right? Greater charge, greater will be the utility. Greater the positive oxygen state, greater will be the utility. That means if you are with a greater electron deficiency, your utility is greater. Greater positive nature means greater electron deficiency is appearing. So when it is high, right, your utility is high, right? That is the idea. So utility is a measure of electron deficiency. That is what applied there. When you are connected to more of electron negative atoms, that means all the atoms those atoms will attract electrons from your atom, so that your atom's electron deficiency will be high. That is why we say your considering atoms utility will be high, right? That is the idea there, the electron deficiency idea, right? So anyway, those things should be used to come up with the utility variation, right? Let's see. Among these 2 carbons, let's consider first consideration is hybridization. Hybridization. This guy is with 1, 2, 3 sp2. This guy is with 1, 2 sp. sp hybridization is with more S character than the sp2. 50% of S character. Out of 3 orbitals, only 1 is 33% of S character. So greater S character appears with sp. So greater S character, greater will be the utilities. So C3 is with a greater utility than the C2. Right? C3, C2. When it comes to these two, this guy is with sp2, this guy is with sp. Again, this guy is with a greater S character, sp, 50% of S character, while this guy is with only 33%, right? So more S character here. So N4 is with a greater utility than the N1. Right? That is how the things appear there. Right? So you can do the same kind of question at the 2022, 2023 and 2024. The things appearing in the cute, you can do those, right? The material is like a right? I'll send you the answers. Just do this at home. You do this at home, right? All right. So that is about the electronegativity, what we have ultimately learned, right? Okay. So whisper theory, electronegativity, bond angles, those things have been discussed now, right? හරිද? ඉතින් අපිට ලව තමයි ඉතුරුලා තියෙනවා අයනික් බොන්ඩ් එක, මෙටලික් බොන්ඩ් එක and second interactions ගැන කතා කරන්න මේ යුනිට් එකේ නේ. අයනික් බොන්ඩ් එක කතාව, ඊට පස්සේ මෙටලික් බොන්ඩ් එක ගැන, ඊට පස්සේ second interactions ගැන කතා කරන්න තියෙනවා අපිට. අපි ඒ ටික ඔයගොල්ලෝගේ MCQ set එකත් එක්ක right online session එකේදී කරමු. right? දැන් හෙට දිනනවා, හෙට house right Wednesday night online session එකේදී අපි අර concepts උන මෙටලික් බොන්ඩ් එකයි ඊට පස්සේ වාගේ මොකක්ද තව තියෙන්නේ වාගේ අයනික් බොන්ඩ් එක ගැනයි second iterations දෙකයි cover කරගමු. අර අපිට තියෙන තව MCQ 20ක් විතර ඉතුරුලා තියෙනවා. ඒ ටිකත් එක්කම right හරිනේ. ඉතින් කොහොම තමයි වැඩේ වෙන්නේ. අපි එහෙනම් මෙතනින් පස්සේ යමු ඕගොල්ලෝ calculations පැත්තට right. මොකද අපි මේ month එකේදී අපි cover කරන්න ඕනේ first 3 units ටික හරි. ඒතර calculations cover කරන්නත් ඕනේ. ඉතින් අද mainly මම හිතන් ඉන්නවා calculations වල redox balancing ටික cover කරන්න ඕන. redox equations balance කරන්න කොහොමද ඊට කියලා දෙන්න. ඒතර problem solving වලට යන්නේ අපි. තරම මේ next week එකේ. හරි. તો next week එකේ තමයි problem solving වලට ගිහිල්ලා last 9 years වල වගේ papers ටික කතා කරනවා. හරි. calculation question එක. ඒ තමයි next week එකේ වැඩ ටික. අද අපි කරන්නේ මේ reaction balancing ටික කතා කරන එක. right. There are basically 4 types of reactions available no? right with the chemical calculations. right thermal decompositions ඊට පස්සේ තව දිගට හතරන්නේ ඊට පස්සේ acid base precipitation and the redox right. redox වලින් start කරමු. ඕකනේ වැඩිම තියෙන කාරණේ. අර දෙක නිකන් හරි වට්ටෝ ටියුට් එකක් නෝට් එකක් බලලා ඉගෙන ගන්න පුළුවන්. redox කතාවක් තියෙනවා පොඩි. redox වලින් වැඩි පටන් ගමු right. so let's come to the next tute right. green color tute එකට එන්න. අපි ඒකේ predict කරන්න පටන් ගමු right. right. ඉතින් මුලින්ම අපි කරන්න යන්නේ මේ oxidation state එකයි හොයන එකයි ඊට පස්සේ මේ redox balancing ටික හරිද? අද balancing ටික ඉගෙන ගමු. එතකොට අපිට ඊට use කරලා questions කරන ටික next week කරන්න ඕන. ඉතින් කොහොම හරි ළමයි මේ plan එකට stick වෙන try එකක් දෙන්න. හරිද? දැන් අපිට මොනවා හරි වැඩිපුර කතා කරන්න මිස් වුණොත්, කරන්න බැරි වුණොත්, ඊට ක්ලාස් එකේදී අපි ඒවට මේ වීඩියෝස් හරි උගලට ප්‍රොවයිඩ් කරනවා. හරි? ඉතින් ඒ ටික කරලා කොහොමද මේ plan එක stick වෙන try එකක් දෙන්න. හරිද? එතකොට අපිට මේ syllabus එකම cover කරගන්න පුළුවන්. මේ මාස 6 ඇතුළත. හරි month එක අන්තිමට අපිට මොනවා හරි දෙයක් ඉතුරු වුණොත් ඉතුරු වෙන්නේ නැති වෙයි. අපි උපරිමයෙන් කරනවා right මොකක් හරි පොඩි පැයක වගේ වැඩක් ඉතුරු වුණොත් අපි ඒකට වීඩියෝ එකක් දෙනවා right. ඉතින් කොහොම තමයි වැඩේ යන්නේ. කොහොම හරි මේ content එක මාසෙකට cover කරගෙන try එකක් දෙන්න. හරිද? right. let's come to the chemical calculation stuff right. හරි. ඉතින් අද මම අර ඔයගොල්ලෝ පොඩ්ඩක් ට්‍රේන් වෙන්න පුළුවන් නේ සතියකුත් තියෙන නිසා ට්‍රේන් වෙන්න. හරි. අමාරු වැඩි කියන්නේ. redox reaction balancing ඉදි. අර ඒ වැඩේ පොඩ මතක් කරන්න. ඉතින් ඔයගොල්ලෝ පුළුවන් වෙයි කියලා මම හිතනවා. නමුත් කමන්නේ අපි මුලින්ම කතා කරමු redox reaction balancing කොහොමද කරගන්නේ කියලා. හරි. right. so redox reactions පැත්තට තමයි යන්නේ. redox reaction balancing වලට කලින් නෑ මුලින්ම අපිට oxidation state කියන එක කතා කරන්න වෙනවා නේ. oxidation state. oxidation state. That is the basis of redox balancing, right? First of all, right? So multi පොඩක් කියවගන්න basic concepts එකෙන් දීනවනේ. දැන් සාමාන්‍ය දේවල් ටික හරි. අපි එහෙනම් මුලින්ම මේ කතා කරන්න යන්නේ ඔයගොල්ලෝගේ page number 5 වල දිනනවා oxidation state එක හොයන හැටි ගැන. හරි? එතනින් තමයි පටන් ගන්න යන්නේ. ඉතින් අපි නේ redox balancing එක කරන්න කලින් oxidation ටික හොයාගන්න පුළුවන් ඉන්නේ. හරි. ඕකනේ දුක් කරගන්න බෑ. හරි. ඉතින් දැන් වැඩිට යන්න. ඊළඟ මෙතන ගොක්ලාට අර questions වල ඇහෙන දේවල් මෙතන තමයි කතා කරන්න. හරිම පොඩි වෙලාවක් නේ අපිට දෙන්නේ මේ වැඩේ කරන්න. හරි. සාමාන්‍යයෙන් දැන් මේ අපි ළමයි අත්‍තරම අවුරුදු දෙකමාරකින් කරන වැඩේ තමයි මාස 6න් ගතින් කරන්න යන්නේ. ලොකු වැඩක් කරන්නේ. ඒකට අර ඔයගොල්ලන්ට මේ බේසික්ස් ටික තියෙන නිසා හරි වඩාත්ම වටිනා ටික තමයි questions වල අනිවාර්යයෙන්ම ඕන කරන කාරණා ටික තමයි මෙතනදී කතා කරන්නේ. හැබැයි ඔයගොල්ලෝ note එක ගැන කොහොමද දාලා තියෙනවා. short note කරලා. ඒ ටික පොඩ්ඩක් කියව ගන්න. පොඩ්ඩක් කියවලා ලේසියෙන් අයිඩෙන්ටිෆයි කරගන්න පුළුවන් විදිහට තමයි දාලා තියෙන්නේ right. ඉතින් අර ටිකක් තනියම ඉගෙන ගන්න ටිකක් අමාරු දේවල් ටික මෙතනදි කතා කරනවා right හරි බලමු එහෙනම් මුලින්ම කතා කරමු මේ oxygen state and how to find the oxygen state when the chemical formula is given right okay that is what we are referring to today right first thing what is oxygen state නිකම් මතක් කරගමු oxygen state ඉතින් මේක කියලා නෑ ඒක මොකද්ද කියලා oxygen state right what is that අහන්නේ නෑ ඉතින් කවුරු අහන්නේ තමයි මේක තියෙන්නේ හරි නෝට් එක අරන් තියෙන විභාගයේදී අහන්නේ ටික හරි ඉතින් ඔය නිකන් ගියේ මොකක්ද දැනගන්නේ oxygen state කියන්නේ මොකක්ද ඒක නිසා පොඩ්ඩක් කතා කරන්නේ what is oxygen state so according to research book it says like this oxygen state of a considering atom is the charge of the atom if all the bonds are considered to be ionic. The charge of the atom if all the bonds are considered to be ionic. Right? That is referred to as the oxygen state of a considering atom. Body example like me wage. So you have NH3. Right? So what is the oxygen state of nitrogen here? The idea is this. If you have to think of all the bonds here as ionic, the charge on the nitrogen is referred to as the oxygen state, right? So the main bond is ionic now, right? The two electrons are actually going towards the most electron-negative atom now. So nitrogen is more electrons than hydrogen, so that right the two electrons are even the hydrogen electron will go towards nitrogen, so that nitrogen will have both the electrons, right? That means hydrogen get a positive charge and nitrogen gets a negative charge there because of ionization of this bond. ඒක අත්‍තරම මෙහෙම දින්න ඕනේ මේ වැඩි මෙහෙම තිබ්බ බොන්ඩ් ඉලෙක්ට්‍රෝන්ස් දෙක හයිඩ්‍රජන් ඉලෙක්ට්‍රෝන්ස් මෙතනට ගියා. එතකොට නයිට්‍රජන් නෙගටිව් හයිඩ්‍රජන් පොසිටිව්. සරලව කිව්වොත් ඔයාගේ more electronegative atom will get a negative charge while the electropositive atom gets a positive charge if the bond is considered to be ionic. මේ බොන්ඩ් එක ඉලෙක්ට්‍රෝන්ස් මෙහෙම එනවා එතකොට right නේ. So the charge around the atom, if all the bonds are considered to be ionic, what is the charge around the nitrogen? 1, 2, 3, minus 3. So that is the oxygen state, right? So this nitrogen's oxygen state is minus 3. That is the definition, na? May I oxygen state here? Last one, right? That is the definition. Normally, oxygen states are denoted inside brackets. Inside brackets, we write the oxygen states. පොඩ්ඩක් එහෙම ලියන්න ඕනේ. oxygen states කවදාවත් brackets එකතු තමයි ලියන්නේ නැහැ හොඳේ. bracket එක නැතුව ලියුවොත් අපි ඒකට කියන්නේ charge එක කියලා. If you are writing some number with a sign even without a bracket, normally we consider that as the charge of the atom. Inside brackets, that is the oxygen state. When all the bonds are considered to be ionic, that's a hypothetical situation, right? That is a hypothetical situation, oxygen state, right? That is the idea. So, with the use of the Lewis structure, you can come up with the oxygen state like this, right? With the definition and the Lewis structure, we can come up with the oxygen state like this. But in chemical calculation questions, we are not supposed to, right, derive the oxygen state with the use of Lewis structure, right? In chemical calculation questions, right, we use the algebraic method to come up with the oxygen state, right? In our A-level syllabus, there are two methods to find out the oxygen state. One is this, using Lewis structure. Give the minus charge to the electronegative atom, give the positive charge to the electropositive atom, and then count all the charges around the atom. That will give you the oxygen state. That is one way of finding the oxygen state. But in chemical calculations, the question at the essay paper, we are not supposed to use this thing. We are supposed to use the other method of finding out the oxygen state, which is known as the algebraic method. So today, we are going to discuss about that thing. We are going to start up with that thing, the algebraic method, right? And how to come up with the oxygen state with the use of algebraic method. That is our consideration today, right? First consideration today. Right. Before using the algebraic method, you should know some basic stuff which are appearing in your table there at the page number 5. Page number 5 එකේ table එකක් තියෙනවා. මේ table එකේ තියෙන basics ටික ඔයාලා දැනගෙන ඉන්න ඕනේ. හරි. ඉතින් දැනනවා නම් විතරයි ඔයාලට algebraic method use කරන්න පුළුවන් වෙන්නේ oxygen state එක use කරන්න. හොයාගන්න. Right? So what are the basics you should know? See, ටක් ගාලා ටික මතක් කරගන්න. මෙන්න මේ ටික දැනගන්න ඕනේ. Basics ටික. හරි. First thing. Right, when considering a chemical formula, right, right, if the elemental state is considered, that means only one kind of atom is there, one type of atom is there, elemental state without a charge. One type of atom without a charge, elemental state, like O2, F2, right? Helium, hydrogen, Cl2, S8, right? Elemental state. One type of atom is there without a charge. These are elemental states. These are compounds. These are compounds. These are compounds. Two kinds of atoms, two types of atoms, right? But when regarding elemental state, right, the oxygen state is equal to 0. The oxygen state is 0. Samani yatin තමයි 0. 0. 2 atoms with oxygen state 0. 8 atoms with oxygen state 0. Right? That is the first thing. Then regarding elemental state, the oxygen state is equal to 0. Right? Done no? Second thing. When regarding monoatomic ions, these are stuff in your table, right? When regarding monoatomic ions like this, monoatomic ions with a single atom. See, F is 2 plus, F is 3 plus, Cl minus, S2 minus, H minus, monoatomic ions, N3 minus, monoatomic ions. When it comes to monoatomic ions, the oxygen state is what? Is equal to charge of the species plus 2, plus 3, minus 1, charge of the ion minus 2, minus 1. Normally oxygen state is written inside brackets, directly down below the considering species, considering atom, right? Third point. Considering compounds, some specific atoms in compounds, right? Okay, first the halogens, fluorine in compounds. That is the third one, no? Sorry. They have given the S block acid. Anyway, let's consider fluorine first of all. Fluorine in compounds is number 4 in your table, right? Fluorine in compounds like this, HF, right, OF2. Fluorine in compounds, ne? Compounds කියලා කියන්නේ එක ජාතියකට වඩා atoms ලා ඉන්නෝනේ. මේක fluorine's elemental state. One kind of atom is there. Fluorine in compounds, more than one kind of atom is there. So these are compounds, right? Fluorine in compounds. So like NaF, right? Right? CaF2. Fluorine in compounds always come up with -1. Fluorine in elemental state is 0. In compounds -1. Right? Compounds කියන්නේ species with more than one atom and the net charge is 0 compound. Right? Fluorine in compounds. Even in ions. කොහේ හරි fluorine ඉන්නවා නම් ඉතින් හරි ඒක තමයි. Compounds or ions. මේක මොකක් කර අපිට ion එකක් ගන්න පුළුවන්ද? Fluorine ion වලින් set වෙන්නේ කොහොමද fluorine කොහේ හරි compounds ions එක ඉන්නවා නම් ඒක -1. නිකන් අර මොකක් හරි අර මෙහි එකක් අත්තොත් CaF4 2- හරි ගමන්නේ. ඒ කියන්නේ මෙයා ඇවිල්ලා හරි කොප්ප හරි මොකද මේ fluorine in ions. Fluorine, right, elemental state is 0. Fluorine කවුරු හරිත් එක්ක set වෙලා නම් ඉන්නේ -1. ඔය විදිහට fluorine තියෙන්නේ. හරි? right? ඔය fluorine කතාව තියෙනවනේ පැහැදිලි. Fluorine in compounds or ions, complex ions තමයි. හරි? Fluorine situation. Some more S block guys. හරි? Group 1 guys in compounds. Group 1's elemental state 0. Group 2's elemental state 0. තනියම ඉන්නවනේ 0. But compound form like this. Group 1's in compounds. NaF හරි කමන්නේ. Na2O. Right? Potassium sulfate. Right? Rubidium, carbonate. Group bonds in compounds, always +1. Always +1. Group bonds in compounds. Group 2s in compounds. Magnesium chloride, all compound type, group 2s. Post P. Group 2s in compounds. Right, calcium, barium sulfate. Group 2s in compounds, always come with +2. Group 1s in compounds +1, group 2s in compounds +2. Right? What else? Right? Hydrogen. Hydrogen. Hydrogen can show the +1 as well as the -1, other than 0, right? Hydrogen in compound, hydrogen in elemental form 0. ඒක කවුරුද දන්නවනේ? Elemental compound form එකේදී නැත්නම් ions form එකේදී hydrogen ට +1 පෙන්වන්න පුළුවන්, +2 පෙන්වන්න පුළුවන්, +1 පෙන්වන්න පුළුවන්, -1 පෙන්වන්න පුළුවන්. Right? Okay, hydrogen like hydrogen in compounds. Right? Hydrogen in compounds or ions. Hydrogen in compounds or ions. When the hydrogen is connected to a non-metal, it is coming as +1. Hydrogen connected to non-metal. Sulfur is a non-metal. Oxygen is a non-metal. Nitrogen is a non-metal. Hydrogen connected to non-metals, +1. When hydrogen connected to metals, sodium hydride, metals, magnesium hydride, aluminium hydride, or even the AlH4 minus in organic chemistry, lithium hydride, sodium borohydride, those things, right? So when connected to metals, metal hydrides, the hydrogen comes up with -1. Non-metal hydrides +1 for hydrogen, metal hydrides -1 for hydrogens. Right? Okay. Finally, about the oxygens. Right? Normally, oxygen shows the -2. Oxygen's normal value is -2. Oxygen's normal value is -2. Right? H2O, sodium oxide. Right? So magnesium oxide, aluminium oxide. Oxygen's normal value is -2. Right? And there are two special values for oxygen coming up with the fluorine. Right? Oxygen gives you the +2, right? Only with the fluorine, OF2. Oxygen coming up as plus oxygen states only with the fluorine. Fluorine is the only atom which is capable of attracting electrons from the fluorine, right? From the oxygen, right? So oxygen shows the positive oxygen states only with the fluorine. Normal value is this, Normal value is this. Hydrogen's normal value is this. Only with metal hydrides, hydrogen comes up as -1. Only with OF2, oxygen showing some different values, and only with the OS2, oxygen shows some positive value, and -1 value can be shown with the peroxides. O2 minus form coming up with -1, like H2O2, right? Then Na2O2 peroxides. The group 1s are able to form the peroxides as well as the hydrogen. In group 2, only the barium is able to form the peroxide, right? In the superoxide, you have the 0 and -2 but -1, but that is not involved in these calculations. In these calculations, the superoxide form is not involved. No need to worry about that superoxide form. But the peroxides are normally involved, right, with H2O2 as well, right? So what are oxygen superoxide එකන ඔරු වෙන්න එපා එච්චර. ඒක නිකන් calculation සාහන ගන්න නෙමෙයි. ඉතින් අහන්න තියෙන ඔරු වෙන්න එපා ඉතින්. දැන් මේ අන්තිම වෙලාවනේ ඔය හැතින හැමදේම උළුවට දා ගන්න බෑනේ. හරි. note එකේ තියෙනවා හැබැයි වැඩි ඔරු වෙන්න එපා. Peroxides coming up as -1 for the oxygen, right? But normal value, the general value for oxygen is -2, right? With this knowledge, actually we can find the oxygen state with the use of algebra method. Let's see how to use the algebra method to find the oxygen state of a bonded atom, right? කොහොමද අපි oxygen state එක හොයන්නේ කියලා බලමු algebra method එකේ මේ ටික හරිනේ. ඉතින් දිනවා වාගේ කතා වශයෙන් නේ, right? table එකේ දිනවා. right? බලමු එහෙනම් මේ ටික use කරලා කොහොමද වන්නේ කියලා. හරි? ඉතින් මම ඔයාලට අද simple method එකක් කියලා දෙනවා වැඩි කරන්න. හරි? මේ method එක use කරන්න. හරි? දැන් ඔය note එකේ වාගේ resource book method එකක් තියෙනවා. හරිද? shortcut method එකකුත් තියෙනවා. ඔයා shortcut method එක use කරනොත් resource book method එකට ගිහිල්ලා මේක කරන්න පුළුවන් කමක් නැහැ. හරි? ඒතර oxygen state එක හොයන්න යනවා මිනිත්තුවක් විතර. oxygen state එක හොයන්න මිනිත්තුවක් විතර ගියාට පස්සේ නේද? reactions 4ක් විතර redox reactions 4ක් විතර ලියද්දි හරි? එක redox reaction එක oxygen state හොයන්න 4 සැරයක් තියෙනවා. එතකොට redox reaction 4ක් ලියද්දි මිනිත්තු 16ක් යනවා. oxygen states එක හොයන්න විතරක්ම redox reaction 4. හරි? ඒක කරන්න පුළුවන් වැඩක් නෙමෙයි ළම. හරි? ඒක නිසා අපි resource book method use කරන්නේ නැහැ මේකට. අපි මේකට shortcut method එක use කරන්නේ algebra form එකකින් oxygen state එක හොයන්න. හරි? බලමු ඒක කොහොමද අපි use කරන්නේ කියලා. right? okay. so let's come up with these stuff, right? මම මේ දීලා තියෙන examples ටික ගන්න. pH3 හරි? දීලා තියෙනවා. ඊට පස්සේ තව example එකක් දෙනවා ඔයාලට H3PO4 තව example එකක් දෙනවා SO4 2-. මේ වැසියල් දෙන්නේ. හරි. දැන් ඉතින් මෙන්න මේ atoms ලගේ oxygen states හොයන්න ඕනේ කියලා මෙන්න මෙයාගේ phosphorus ගේ මේකේ phosphorus ගේ sulfur ගේ. හරිද? මෙන්න මෙහෙම කරන්න ළඟ ඉඳලා ලේසි විදිය හරි. මුලින්ම oxygen state එක හොයන් තියෙන atom එක නැතුව මෙයන් හොන්දි අනිත් atoms වල සේරගෙම oxygen state එක ටිකේ summation එක ගන්න. just take the summation of all the other atoms, the summation of oxygen states of all the other atoms than the required atom, right? හරි. දැන් ඒක කීයද? මුලින්ම කරන්න ඕනේ ඒක. කීයද උඩ? you have 3 hydrogens, one hydrogen carry +1, 3 hydrogens means +3. හරි? දැන් මේක දැන් හොයන්න ඕනේ. ඊට පස්සේ මොකද කරන්න ඕනේ? ඊට පස්සේ ඒකේ opposite value එක ගන්න. so එතකොට -3 +3 ගේ opposite එක -3. ඊට පස්සේ මෙතන තියෙන charge එක එකතු කරන්න. එතකොට -3 charge 0 නේ. -3 + 0 -3 තමයි. so oxygen state of phosphorus is -3. හරි? ඕක ඔළුවෙන් කරන්න ඕනේ. මෙහෙම ලියලා ඉන්න ඕනේ. මේක. හරිද? බලන්න මුලින්ම hydrogen 3 දෙනයි. so +3 4 of oxygens -8 -8 +3 -5. hari? take the opposite of that thing +5, right? add the charge here +5 +0 +5 තමයි. phosphorus oxygen series +5. මේක charge එකක් තියෙනවා බලන්න. 4 of oxygens -8 -8 take the opposite +8 add this number +8 -2 +6, right? within brackets ලියන්න oxygen state. හරි? ඉතින් අපිට ඕක ලේසියෙන් ගන්න පුළුවන්. unit 1 වල සමානයි. හරි. නමුත් ඇත්තටම second decimal එකේ වෙනස් වෙනවා. ඒතර algebra method එක use කරන මොකද්ද? මොකද මතක තියාගන්න ඇල්ජිබ්‍රික් මෙතඩ් එක ඇල්ජිබ්‍රික් මෙතඩ් එකෙන් දෙන්නේ හරිම වැලියු එක නෙවෙයි. හරි? ඇවරේජ් වැලියු එකක් පිළිගන්න පුළුවන් වැලියු එකක් දෙන්නේ. හරිම වැලියු එක දෙන්නේ ඔයාගේ ලුයිස් ස්ට්‍රක්චර් එකේ. හරිද? ඒකත් පොඩ්ඩක් ඔළුවේ තියාගන්න. දැන් ඔය S2O3 2 minus ගාව ගත්තා පස්සේ මේ ඇල්ජිබ්‍රික් මෙතඩ් එකකින් ඉන්නේ +2 කියලා. එහෙනම් +2 එකක් නැහැ එතන. S2O3 2 minus වල තියෙන්නේ සල්ෆර් දෙන්නේ ඉන්නේ +4 and 0. Average is +2. With the algebraic method you get the average value, right? හරිද? ඒකත් ඔළුවේ තියාගන්න. That is enough to balance the error of reactions, right? මේක අර අහ ප්‍රශ්න මම දෙයක් කියන්න. PH3 වල වාගේ පොලි ස්කේල් එක යුනිට් 1 වල තියෙන්නේ 2.1 2.1 කියලා. ඉතින් ඒක එහෙම පිළිගන්න එක හරි. නෝ සෙකන්ඩ් ඩෙසිමල්ස් වලට ගියාට පස්සේ කතාව පොඩ්ඩක් වෙනස් වෙලා මේ වැඩේ වෙනවා. හරිද? ඒ කියන්නේ worry වෙන්න එපා. මොකද රිසර්ච් බුක් එකෙන් පැහැදිලිවම කියනවා hydrogen with non-metals it is going to be carrying some -1, sorry +1. Hydrogen with metals should carry -1. So මේ +1 in +1 තුනක් වෙනකොට +3 එනවනම් මෙතන 0 වෙන්න summation should be gain -3 වෙන්න ඕනේ. ඒක අවුලක් නැහැ. right? pH 3 එක calculate කරන්න ගියොත් oxygen state මොකක්ද කියලා -3 කියලා ලියන්න. හරි? අරකට ඔලිය තියාගන්නේ වැරදි නෑ. Hydrogen is with the same unity as the phosphorus. අර second decimal එකෙන් තමයි out යන්නේ. Pauling scale එක මුලින්ම Pauling scale එකට සමානයි. Pauling scale එක දාලා තියෙන්නේ first decimal එකට. දැන් ඕගොල්ලෝ Google එකෙන් search කරලා බලුවොත් තියෙනවා second decimal එකට නම් දැන් හොයාගෙන තියෙනවා. දැන් Pauling scale එකට එන්නේ first decimal එකට. කොට තියෙන එකයි හොර වෙන්න එපා. හරි. Pauling scale එකට සමානයි කියලා ගන්න. හැබැයි pH එකේ oxygen state එක -3 කියලා ගත්තට අවුලක් නැහැ. calculation කරන අනිවාර්යෙන් -3 ගන්න ඕනේ. හරි. right. එතකොට ඔහොම තමයි වැඩේ යනවා. තව එකක් ඕනනම් කියලා දෙන්නම් මේවා. මේ මොකක් හරි තව කේස් එකක් ඕනද? right fourth එක ඉහම බලමුත්. මොකක් හරි MnO4 minus කොහොමද ගන්න? මේවා මෙයාගේ ඕනේ. හරි. එතකොට 4 of oxygens means -8. මම කතර ලියන්න. 4 of oxygens -8. එහෙනම් +8 +8 -1 +7. ඔහොම එක සැරේ ගන්න. ආයි ලිලි ඉන්න බා. right නේ? දැන් මේ තව එකක් බලන්න. හරි ඔගේ ඔය නිකන් CrO4 2 minus 4 oxygens -8. එහෙනම් මෙයා +8 +8 -2 +6. හරි? කතරේ ඔලුවෙන් ගන්න. පැහැදිලිව ගමු නේ. 4 of oxygens -8 +8 +8 -2 +6. right නේ? ඉතින් ලේසි ඔලුවෙන් ගන්නවා. ලියලි ඉන්නේ මෙහෙම ලියලි ඉන්නේ නැහැ හොඳේ. ඔලුවෙන් ගන්න හදන්න ඩක් ගලෝ. හරි? I think it's okay, right? To copy the oxygen state, right? හරි. තව දෙකක් විතර ලියන්න දෙන්න. ටක් ගලවන්න. මම පොඩි එකක් දෙයක් කරමු ඔන්න. මේ 6. ටක් ගාලා ටින් ගේ right bromine ටක් ගාලා වලින් ඔක්සිජන් සෙට් එක shape ni agak belum kan වෙලා ගන්න ඔය එක තමයි. එතන මෙතන ඉන්නවා -4 ඉන්නවා. -4 මේ දෙන්නගේ. එහෙනම් මෙයා +4 +4 -2 +2. මේක -6 +1. එතකොට -5 මේ දෙන්න -5 එනවා. එතන මෙයා +5 +5 0 +5. अनिवार्य within brackets sign लेते हैं, right? Okay, that is done. Right, find the oxygen states. Shape में, हाँ. Then इन्हें टक गाले आंग balanced redox reactions. Right? Balanced redox reactions. Right? So there are two methods available. There are two methods available to balance redox reactions. Right? Two methods available. Right? What are the two methods? Right? Direct balancing technique and the half reaction technique. Right? So basically for the chemical calculations, we go for direct balancing technique. Chemical calculation වල මේ half balancing දාලා ඉන්නේ නැහැ හොඳේ. පැය ගාණක් යනවා තුන්තරය balance half balancing එක ඇත්තට තුන්තරය balance කරනවා. ඔයා තුන්තරයක් H+H2O දාලා balance කරනවා. Oxidation half එකට එක සැරයක් balance කරනවා H+H2O දාලා. ඊට පස්සේ reduction half එක තව සැරයක් balance කරනවා. එකතු කරන්නේ ආයෙත් balance කරනවා. ඔහොම වෙලාව ගන්න බෑ. Chemical calculation question එක. For the chemical calculation questions, we go for direct balancing method. හරි. එහෙනම් මොකටද half balancing method එක උගන්වන්නේ? Then why we are learning that thing, the half balancing technique? That is very important to do the unit 13. තාම කරේ නෑ අපි ගන්න තියෙන්නේ. හරි. ඉස්සරහට දැන් කරන් දින මේ මාස අන්තිමට කතා කරනවා. The unit 13 අපි කතා කරනවා මේ next week එක. ඒතර මේ පටන් ගන්නවා electrochemistry දවස් දෙකක් වැඩි ඉවර කරන්න යන්නේ. ඒතර මේ electrochemistry වල anode reaction, cathode reaction. At the anode, oxidation occurs. At the cathode, reduction occurs. To write the anodic and the cathodic reactions of electrochemical cells as well as the right electrolytic cells, right? We should know that technique, the half reaction balancing technique. හරි? එතකොට ඕකට තමයි ඒක ඉගන්නන්නේ. half reaction balancing technique එක උගන්වන්නේ ඔයාගේ chemical calculation එක කරන්නේ නෙමෙයි. ඒක උගන්වන්නේ ඔයාගේ question number 7 part B කරන්න. Question number 7 part B is regarding electrochemistry. 75 marks are allocated there. To do that only, we are teaching you that half reaction balancing technique. Right? Okay? එකක් තියෙනවා. කොහොමද අපි මුලින්ම මොකක්ද කතා කරන්නේ? Direct balancing technique. Right? Let's learn the direct balancing technique of redox reactions. ටක් ගලවන direct balancing කොහොමද කරගන්නේ කියලා. Let's go through the steps there. Right? Step by step ගිහිල්ලා direct balancing කරමු. Right. Okay. So that is at the page number 6. Page number 6 එකේ already direct balancing technique ගැන කතා කරලා තියෙනවා. Steps ටික දාලා තියෙනවා. බලමු කොහොමද මේක use කරන්න කියලා. I'll do the same example to begin with, right? So this is all about redox balancing, redox reaction balancing. Right? Direct method. Sometimes it is referred to as the oxidation number change method. Oxidation number change method කියලා තෝ කියනවා. හරිද? බලමු. මම අර example එකම ගන්නම් ඔයාගේ. As an example, I'll take the same thing, right? As an example, I'll come up with the same one. Acidic medium, dichromate guys reacting with SO2 to produce the Cr3 plus and the SO4 2 minus. Right? අපි මේ reaction එක direct balancing technique එකෙන් balance කරමු. හරිද? Right. මෙහෙම වැඩි වෙන්න ඕනේ. දැන් ඔයාලා වැඩි වෙන්න තමයි කරන්න ඕනේ. හරි? Step 1. Step 1. හරි? මුල්ම step එක. හරි? ඉතින් මේක ලියා ගමුනේ. මුලින්ම ලියන්න මෙයා හරි? මේක ඇල්ල ඕනේ. step 1. හරි? step 1. යන්න කලින් මට ලියා ගමු ඕනේ. මම මෙහෙම ගත්තනේ මෙයාම. මෙයා balance කරන්න ගම යන්නේ. Step 1 of this balancing. Right? Step 1 of this balancing. Right? First identify the oxidation couple and the reduction couple. Oxidation එක couple එක reduction couple එක identify කරේ. ඒක අමාරු නෑ. කොහොමද වහගන්නේ? අර ඔක්සිජන් නැතුව තියෙන ඉතුරු ඇටම් එක ගන්නකො. මේක ඔක්සිජන් නැතුව තියෙන ක්‍රෝමියම් නේ. හරි. එතකොට ක්‍රෝමියම් තමයි. ක්‍රෝමියම් ඉන්න කවල් එක. මේකේ සල්ෆර්නේ. සල්ෆර් ඉන්න කවල් එක. එකක් මේක අනිත් එක මේක. හොඳ කවල්ස් දෙක. හරි. අයිඩෙන්ටිෆයි කරන්න අමාරු නේ. ඔක්සිජන් හයිඩ්‍රජන් නැතුව ඉතුරු ඇටම් එක කන්සිඩර් ඉතුරු හරියට සෙට් වෙනවා. ඕක පොඩ්ඩක් කර මිස් වෙන්නේ H2O2 ඉන්වෝල්ව් වෙන තරඟ විතරයි. H2O2 ඉන්වෝල්ව් වෙන්නේ නැත්නම් සරලව ඔක්සිජන් හරි හයිඩ්‍රජන් හරි නැතුව ඉතුරු ටික ගන්න. එතකොට හරි. එතකොට ක්‍රෝමියම් ඉන්න කපල් එක. සල්ෆර් ඉන්න කපල්. Identifying the redox couples. Right? Chromium half and the sulfur half. Right? First step එක ඉන්නේ. ඊට පස්සේ first thing to do is identify the redox couple and balancing the redox atom. Balancing the redox atoms. දැන් මේකේ chromium ලා ගියක් ඉන්නවද දෙකක් ඉන්නවනේ. නේද? දෙකක් ඉන්න ඕනේ. First step identifying the redox couples and balancing the redox atoms. Sulfur එක්කෙනයි sulfur එක්කෙනයි. Done. First step done. Identify the redox couple and balancing the redox atoms. First step done. එක රූලේ වැඩි ඉවරෙන්න ඕනේ. එක රූලයි. One line. Second step. Right? Second step. Right? Coming up with the oxygen state. Right? Coming up with the oxygen state and try to balance the oxygen states. Follow? Coming up with the oxygen states and try to balance the oxygen state with the use of electrons. Right? Balancing the oxygen states with the use of electrons. So for that, you have to write the oxygen states here. Right? Make you. මෙතන වාඩි ඉන්නවා 7 of oxygens. මේ oxygen state එක. 7 of oxygens minus 14. මෙතන එනකොට plus 14. minus 2 plus 12. summation එක ගන්න හොඳේ. I plus 12 දෙකෙන් බෙදලා plus 6 එහෙම දාන්න නෑ හොඳේ. ඒක මට වඩා නෑ. අදාළ නෑ ඒක. මුලින්ම redox atoms balance කරලා පස්සේ කෙලින්ම sum එක ගන්න. chromium ඉන්න හැමෝගෙම oxygen state value එක. හරි? මෙයා කියද you have 2 of Cr3 pluses. So that is සරල ඕනෙලෙන් plus 3 plus 3 plus 6 කියන තමයි තියෙන්නේ හරි. කෙලින් plus 6 කියලා ගත්ත කමන්නේ හරි. 2 of කියන. So the difference is yes 6 units of difference. Right now? With the other guy, it's got leave though. In a body leave. Sulfur. 2 oxygens are there, minus 4. That means this sulfur coming up with plus 4. This sulfur. Minus 8 with 4 oxygens, minus 8. So this one, plus 8 minus 2 is plus 6. Right? So the difference is 2 difference. Now balancing. The least common multiple is 6. So to compare 6, you need to multiply this thing with 3. 3, 3. To compare 6, you need to multiply this thing with 1. Multiply with 1. 1 එක ලියන්න දෙන්නේ. That is the end of the second step. හරි? මුලින්ම කරේ redox atoms balance කරන එක. ඒක නිසා දෙකක් දැම්ම මෙතනට. මේ balance කරන්න දෙයක් තිබ්බේ නැහැ. දෙවෙනි කරන්නේ right? Balancing the oxygen states with the use of electrons. Right? They are the least common multiple also involved. එතකොට difference එක ගත්තා. plus 12 plus 6 difference එක 6යි. difference එක 2යි. Take the least common multiple to balance the stuff. Least common multiple of 6 and 2 is 6. So you need to multiply this in 3. This thing with 1. Done. Right? Second step. Third step එක මොකදරන්නේ? Third step is to balance the charge of both sides. So charge of this side, you have minus 2 here, one particle of minus 2 here, 0 here. So the charge of this side is minus 2. Charge of this side is minus 2, 0. Charge of this side, 2 particles of plus 3, that is plus 6, minus 6. 3 particles of minus 2, minus 6 plus 6, that is 0. Charge. Sorry, remember, charge I am not writing the brackets when I am writing the charge. When I am writing the oxygen states, I am coming up with brackets. හරියට ඒවා යූස් කරන්න හරි නැත්නම් අන්තිමට බැටල් එනකොට ඔක්කොම බැටල් වෙනවා charge එකත් වර්ධිනවා මොකක්ද ඔක්සිජන් සෙට් එක කියලා හොයාගන්න බෑ ඔක්කොම ජම්බල් වෙනවා හරියට symbols ටික යූස් කරන්න හරියට so to balance the charge you have a 2 units of difference there as this is an acidic medium situation so you have to use the H plus acidic medium na H plus use karna basic medium na OH minus use karna acidic medium balance H plus so you need 2 units of H plus to balance this 2 units of difference 2 units of difference is there to balance that 2 units of H pluses are needed right to each side H pluses are carrying positive charges H pluses are carrying positive charges so 2 H pluses are needed to this side then only the charges will balance with 0 plus 2 minus 2 is 0 in the width no 0 right finally balancing the hydrogens you have 2 hydrogens here at this side and this side you have no hydrogens right 2 units of difference with the hydrogens so to provide 2 hydrogens you need 1 H2 molecule balancing the hydrogens will be done by H2 molecules right 1 H2 is needed so that is balanced හරිද shape නේද බලන්න ඔය step by step මම ඔය steps ටික ඔයාලට පිළිවෙලට වෙන්නලා දිනවා just go to the note and see whether you understood the concept there step by step මම පැහැදිලිව ඔයාලට page number 6 වල මේක explain කරලා දිනවා ටක් ගාලා කියවලා බලන්න ඊට පස්සේ අපි exercise ටිකක් කරමු let's do some exercises after that හරිනේ එක රූල් එකෙන් වැඩි ඉවර වෙන්න ඕනද මෙහෙම step by step තිබ්බ කියලා මේ step by step තිබ්බ කියලා මේවා රූල් හතරක් පහක් ගන්න බෑ just one single line you have to come up with the answer හරි හොඳට බලන්න මේකේ පැහැදිලිව තේරුම් ගන්න වැඩි හරියද කියලා ඊට පස්සේ අපි exercise දෙන්න ඔයාලට දෙක තුනක් කරන්න තනියම ළමයි දැන් ඉතින් පොඩ්ඩක් මේ ගිහිල්ලා පාඩම් කරන්න හොඳ දැන් මෙතන මේ අපි හයියෙන් මතක් කරගෙන යනවා ඕගොල්ලන්ට හරි මුළු සිලබස් එක මතක් කරන් යනවා මේ හයියෙන් වැදගත් දේවල් ටික ඔක්කොම මතක් කරන් යනවා ඉතින් ඕගොල්ලෝ පැත්තේ වෙන දෙයක් තියෙනවා අනිවාර්යෙන් ගිහිල්ලා දැන් මෙතනින් තියරි ජන්ති දෙයක් හරි මෙතනින් බාගෙට හරි අල්ලන් ගිහිල්ලා හරි ගෙදර ගිහිල්ලා බලන්න හරි බලාලා ඒ ටික මේ කම්ප්ලීට් කරගන්න මේ සතිය ඉවර වෙද්දී ආයෙත් ඒක ඊළඟ වීක් එකට තියන්න එපා හරි ඉතින් මෙහෙම කරන් යන්න ඒකට ඕගොල්ලන්ට එන්න පොඩ්ඩක් ඉස්සරහට යන්න පුළුවන් වෙයි හරිද මේ දන්න දේවලුත් තියෙනවානේ ටක් ගාලා මේ මුළු සිලබස් එක මතක් කරන් යන්න තමයි මේ හදන්නේ හරි ඉතින් අනිවාර්යයෙන්ම ඔයගොල්ලෝ පැත්තෙන් වෙන්න ඕන දෙයක් තියෙනවා ඉතින් මේක මෙහෙම ලියන් ගියා නෙමෙයි තව ගිහිල්ලා ගෙදරදී බලන්න මේ දේවල් බලන්න තව එක්සර්සයිසස් තියෙනවා කරන්න පාස්වෙස් ටික කොහොම එකට දාලා තියෙනවා රයිට් මේ ටියුට්ස් වල දේවල් කරන්න ඕගොල්ලෝ පොඩ්ඩක් මාස්ටර් කරගන්න මේ වැඩි මේ ටක් ගාලා මතක් කරන් දෙන එක තමයි කරන්නේ හරි ඒ කියන්නේ පොඩ්ඩක් අර ඔයාලට පාඩම් කරන්න ලේසි කරන එකයි කරන්නේ ඇත්තටම මේක තමයි කරන්නේ හරි දැන් පාඩම් කරන්න මෙහෙම දෙයක් තිබ්බ කියලා මම ටක් ගාලා ඔයාලට ස්ලයිඩ්ලි මතක් කරලා දෙනවා ඔයා ගිහිල්ලා අනිවාර්යෙන් ගෙදර ගිහිල්ලා පාඩම් කරන්න ඕනේ. දැන් පාඩම් කරන්න ලේසි. ඒ වැඩේ පටන් ගන්න තියෙන්නේ. හරි වැඩේ පටන් ගන්න තියෙන්නේ දැන් පාඩම් කරන්න ඕන කරන බේසික්ස් ටික කියලා දෙන්න තියෙන්නේ. ඔයාට ගිහිල්ලා ගෙදර ගිහිල්ලා පාඩම් කරන්න ඕලුවා. නැත්තම් වෙන්නේ යාර ගෙදර ගිහිල්ලා පාඩම් කරන්න කියලා නේද? පාඩම් පටන් ගන්න ඕන ලොකු වෙලාවක් යනනේ බේසික්ස් ටික ඔලුවට දාගන්න. අර ඒක තමයි ටක් ගාලා මේ කරන් යන්නේ. හරි. ඉතින් ගිහිල්ලා අනිවාර්යෙන්ම ගිහිල්ලා ගෙදර ගිහිල්ලා තව එක්සර්සයිසස් කරන්න. මේ පාඩම් කරන එක කරන් යන්න. ඒක ලේසියෙන් වඩා පාඩම් ටික කරගන්න පුළුවන් වෙයි. හරි. මොකද අර ඔයාව ස්ටාර්ට් එකට අරන් දීලා තියෙන්නේ. හරි. ඒක කරන්න නැත්නම් අපරාධයක් වෙනවා හරි අනිවාර්යෙන් මේ වැඩ ටික කරන්න එතකොට අනිවාර්යෙන් ටයිම් ලයින් එක ඇතුලේ ඉන්න හරි එතකොට කොහොම හරි වැඩ ටික ඉවර කරගන්න මේ මාස ඉවර වෙද්දී හරි සතියෙන් සතිය ඉවර වෙද්දී වැඩ ඉවර කරගන්න හරි රයිට් ඕකේ අපි එක්සර්සයිස් එක කරමුද මම ඔයාලට ක්වෙස්චන් දෙක තුනක් දෙන්නම් ටක් ගාලා බැලන්ස් කරලා දෙන්න හරි right මම මීඩියම් එක මෙහෙම දානවා හරි Just try to do the stuff there. I'll give you 10 minutes, right? Taggalava. Right, let's do. Taggala වෙන්න ඕනේ. සාමාන්‍යයෙන් රේෂනල් බැලන්ස් කරගන්න මේ වාට වැඩිමුණුත් මම දෙන්නම් මිනිත්තු එකමාරක් වගේ. Right? 1.5 minutes වලින් වගේ ionic reaction එක balance වෙන්න ඕනේ. Right? Balancing the ionic reaction should be done in 1.5 minutes. Chemical reaction එක තප්පර 2ක් විතර ගන්න ඕනේ. Right? Okay. Let's balance the stuff, right? So number 1. Right, MnO4 minus Fe2 plus, no? MnO4 minus with Fe2 plus giving you the Mn2 plus and the Fe3 plus. Simple one, right? So, oxygen state. So first thing is to balance the redox atoms. So one manganese here, one manganese here. It is balanced. One Fe here, one Fe here. Yes, balanced. Balancing redox atoms. Done. Then balancing the oxygen states with the use of electrons and the least common multiplier, right? So here the oxygen state becomes +7. Here the oxygen state is +2. So the difference is just 5 electrons. Here the oxygen state is +2. Monoatomic ions, right? Monoatomic ions. Right? Oxygen state is equal to the charge of the ion. This +3. So difference is just 1 unit. So least common multiple, right, of 5 and 1 is actually 5. So you need to multiply this thing with 5 to take the come up with the least common multiple. So that branch should be multiplied by 5, right? Okay. So this is 1, right? So no need to write in the ones then. Then the second step is done. Balancing the oxygen state with the use of electrons, that is done. Third step, balancing the charges of two sides. Here -1 and 5 of 2 pluses. 5 of 2 pluses, that means +10. +10 minus 1 is +9 at this side. At this side, +2, 5 into +3 is +15. +15 plus 2 is +17. Right? So, how many units of difference? 8 units of difference. 8 units of difference. So, 8 of H pluses are needed because the medium is acidic, right? 8 of H pluses are needed to provide this 8 units of difference, right? So 8 of H pluses are needed to this side, right? To balance the stuff with +17, right? Finally, the fourth step is about hydrogen oxygen balancing. So let's take hydrogens, right? So 8 hydrogens at this side. At the left hand side, you have 8 hydrogens. So you should have 8 hydrogens at the right hand side as well. So 8 hydrogens are there, but 0 hydrogens are there. So how many units of difference with the hydrogens? 8 units of difference, no? 8 units of difference with the hydrogens. So to provide those 8 hydrogens, you need 4 H2 molecules. 4 H2 molecules, right? So 4 H2 molecules should be added at this side. Right, no? Okay, that is question number 1. Let's do for the second one. Number 2. So acidic medium dichromate Fe3O4. Right. Cr2O7 2 minus reacting with Fe3O4 to give you Cr3 plus and the Fe3 plus. Right. So first thing is balancing redox atoms. So you have 2 chromium atoms here, only 1 single chromium here. So you need to come up with 2 here to balance the redox atoms. 2 chromiums. So you have 3 of iron FVs here, 1 FV here. So you need to come up with 3 here. So the first step is that balancing the redox atoms. That is done. Second step, balancing the oxygen states with the use of electrons. So here, so -14 with 7 oxygens, so +14 minus 2 is +12. So 2 of chromiums, so +3, you can write it as +6. 2 of +3s, right? No worries. So difference is about 6 units of difference, 6 electron difference. Right? To convert the +12 to +6, definitely you have to absorb 6 electrons, right? That is what it indicates here. Absorbing 6 electrons will convert the +12 to +6. Right? Okay, the oxygen states. So here, so you have 4 of oxygens, that means -8 carrying here. So all 3 iron atoms should carry +8. -8, so this is +8. So charge is 0. So with this one, 3 of +3s, that means +9. +3, +3, +3, +9. Right? The difference is just 1 unit. Right? 1 unit of difference. So least common multiple of 6 and 1 is just 6. so you need to multiply this thing with 6. This branch with 6. Coming up with 6 means 18. Right? This is 1. No need of writing the 1 there. Right? Second step done. Balance in the oxygen state with use of electrons. Third step. Charges, charge balancing. So you have minus 2 here. Here 6 into 0. 6 into 0 is 0. Right? 1 into minus 2 is minus 2. So minus 2 at this side. At this side, 2 into plus 3 is plus 6. 18 into plus 3 is plus 54. Plus 54 plus 6 is plus 60. So 62 units of difference. Yes, 62 units of difference. Plus 60 and minus 2. 62 units of difference. And I mean, Gatrabas 0 is there, minus 2 is there, plus 60 is there. In numerical scale. From here to here 60 units are there, from here to here 2 units are there. 62 units of difference. Right? So you need 62 H pluses. To which side? To this side. Then only the things will be balanced with 62. Sorry, 62. Sorry. Yeah, 60, no? Balance is 60. So you need 62 H pluses. The two sides are now balanced with plus 60. Finally, the hydrogen balancing. You can use the H2Os. So you have 62 hydrogens at this side, but you don't have any hydrogens there. So you need 31 of H2Os to provide the 62 hydrogens to this side. Right? So the thing is balanced, right? The oxygens are also balanced, right? 31 oxygens are there. Here also 24 and 7 is 31. Right? That is your equation there. Right now? Let's come up with that one. Right? The third thing. Number 3. Number 3. The MnO4 minus with Cl minus giving you the Mn2 plus and Cl2. Right? In acidic medium, no? So plus 7 here, plus 2 here. So I forgot to balance the chlorines, right? 2 chlorines are there, right? First step is balancing the redox atoms. Right? 1, 1, 2, 2. Right? Then the oxygen states plus 7 plus 2, that is 5 electrons. Here, right, minus 1, 2 of those things are there, so that is minus 2. So this is 0, elemental state, chlorine's elemental state 0. So 2 units of difference. So the least common multiple is 10. 2 and 5 it is 10. So you need to multiply this thing with 5. So 5 into 2 is 10. It's 5. This thing with 2. To come up with the least common multiple 2. Right? Okay, now the charge balancing. Minus 10 is there. Minus 10 is there. Sorry, minus 2 is there. Minus 10 is there altogether. Minus 12. Minus 2. Minus 10. So minus 12. This side plus 4. 2 into plus 2 is plus 4. 0. So altogether plus 4. So 16 units of difference. 16 units of difference. Minus 12 and plus 4. Along with 0. The numbers come, right? Like this. 16 units of difference. So 16 H pluses are needed. The medium is acidic. So the things are now balanced with plus 4. Finally, the hydrogen balancing. You have 16 H pluses at this side. So this side 0 H pluses. So 16 of difference with the hydrogens. So to provide 16 hydrogens, you need 8 H2O molecules to this side. Right now? Okay. Let's come up with the fourth one. It's kind of a basic media stuff. Right? The fourth. That is balancing of this one. In basic medium, aluminum reacting with NO3 minus to give you the aluminate ion and then H3. Right? Okay. It's a basic media stuff, right? Let's do. Right. First, the redox couple balancing, atomic balancing. One aluminium, this is balanced. One nitrogen, this is balanced. Now the oxygen state balancing with use of electrons. 0, this is coming up as plus 3, right? Minus 4, plus 4, minus 1, plus 3. So 3 units of difference, 3 electron difference, and here plus 5 coming up as minus 3, 8 electron difference. Right? Difference is 8 units. So 24 is the least common multiple, so you need to multiply this thing with 3, like this, and this with 8. Second step done. Next step, charge balancing. At this side you have minus 3 charge. At this side you have minus 8 charge. 5 units of difference. Minus 3 and minus 8, 5 units of difference. So you need to come up with 5 of OH minuses. 5 of OH minuses as this is a basic medium balancing. So 5 of OH minuses should be written here. Right now? Final stuff. Hydrogen balancing. You have 5 hydrogens here. You have 5 hydrogens here at this left hand side. At the right hand side, you have 9 hydrogens. 9 hydrogens. 9 hydrogens and 5 hydrogens. So 4 units of difference. 9 hydrogens and 5 hydrogens. 4 units of hydrogen difference. So you need to come up with 2 H2O molecules to provide 4 hydrogens. 2 H2O molecules. To which side? To the side with these hydrogens, to this side. So that is how we are supposed to balance this reaction. Number 4. Let's do the 5 and 6. හොඳට ස්ට්‍රේට් බැලන්සින් එක පුරුදු වෙන්න ළමයි. මොකද next day එකේ ලොකු වැඩක් අපිට තියෙනවා ස්ට්‍රේට් බැලන්සින් එකත් එක්ක. හොඳට මේක පුරුදු වෙලා ඉන්න. හරි number 5. Acidic medium balancing. The I minus and the IO3 minus supposed to give you the I2 from acidic medium balancing, right? This one. So looks like right, you don't have two couples here. Couple දෙකක් නැහැ වගේ නේ. එහෙම බෑනේ එහෙම කරන්න. ඉමඩේ කරන්න බෑ. හරි එහෙනම් මොකද කරන්න ඕනේ? Reduction half එකයි oxidation half එකයි දෙකක් කියලා දෙයක් තියෙන්න ඕනේ. දෙකක් තියෙන්න බෑනේ. balance කරන්න. නේ reduction half එකයි oxidation half එකයි දෙකක් තියෙන්නේ. එතන නැහැ. එකයි තියෙන්නේ. So try this thing again. Actually what happens here is the minus 1 oxidation state and the plus 1 oxidation state of iodine are involving in this reaction. Make it minus 1 ne, make it plus 5 ne. So you have a very stable oxidation state in between the minus 1 and the plus 5 for the iodine, that is 0 oxidation state. So what happens? So minus 1 will oxidize to 0 while the plus 5 will reduce to 0. Such things are very frequently can be seen here, right? Even in this one, right? This is minus 2, this is plus 4. Because of minus 2 and plus 4, the sulfur, some 0, some stable oxidation state is available, right? So one guy will oxidize to 0, the other one will reduce to 0. The same thing appears with here. Minus 1 and the plus 5, one oxidizes to 0 while the other reduces to 0, right? So such things are special things, right? In redox balancing. So let's try to balance this off. So that first of all, what you should do is actually you should multiply this thing. I2 and I2 to clearly see the two halves, the oxidation half and the reduction half, right? So first write the I2 again. Now let's do the balancing, right? Normal balancing. First thing is to do is actually balance the redox atoms. So one iodine here, two iodines are there. So have to put 2 here. One iodine here, 2 iodines are there. So have to come up with 2 here. First of all, balancing the redox atoms. Right? First step done. Second step, balancing the oxygen state with the use of electrons. So here 2 of I minuses. 1 I minus carry minus 1. Such 2 are there. So minus 2. Right? Here this 0 elemental state. So 2 electron difference. Here minus 6 plus 6 minus 1 is plus 5. Such 2 are there. Plus 5, such 2 are there. Plus 10. Right? Here it is 0 elemental state. So 10 electron difference. So you can multiply this thing with 5 to come up as least count multiple 10. Multiply this thing with 5. That means this becomes 10. This becomes 5. Right now? So at this stage we see all the things can be divided by 2. Right? These things can be divided by 2, right? Full then I'm here in 10 of I minus, 2 of IU3 minus, this looks like this, no? 6 of I2, no? Right? So all the things can be divided by 2. So divided by 2 what? So this is going to be 5, this is going to be just 1 and this is going to be 3, right? Divided by 2. Right? Coming from here to here, right? I just divided by 2. Right? Simplify කරන්න stage එක. නැත්නම් නිකන් අනවශ්‍ය නිසා ඔක්කොම ටික නිකන් ඔය වැඩි කර කර යනවා. අනවශ්‍ය විදිහකට. හරි? Right? Okay, now third step, charge balancing. You have minus 5 here, 1 here, minus 6 at this side and 0 at this side. So 6 units of difference. So medium is acidic. So 6 H pluses are needed. 6 H pluses are needed. So that can be written at this side. Finally, the hydrogen balancing. So 6 hydrogens are at the left hand side. No hydrogens there. So 6 units of difference with the hydrogens. So to provide 6 hydrogens, you need 3 H2O molecules, right? So 3 of H2O here. That is how you're supposed to balance the fifth one. Hurry. Passing is right? Hiding a tomb alone. Sixth case, problem number 6. Right? Yes, now we are supposed to balance this one, no? H2S and SO2. Sulfur. So first thing, right? Again, you clearly see the minus 2 oxygen state and plus 4 oxygen state coming up as 0 oxygen state. So you have to write the sulfur twice for the oxidation half as well as for the reduction half. Right? Okay. Now atomic balancing. One sulfur is here, one sulfur is here, it is balanced. One sulfur here, one sulfur here, it is balanced. Right. Then oxygen state balancing, second step, oxygen state balancing with use of electrons. So the oxygen state of sulfur here is minus 2 for the H2S, it's plus 4 for this SO2. right? Here it is 0. Sorry, I put it right here. 2 halves, right? 0 and 0. So here the oxidation state difference is 2 units. Here also, no, here it will come up as 4 units. Right? So least common multiple is 4. Least common multiple is 4. You need to multiply this thing with 2 then. So this branch with 2. Right? This is 1. So after this stage, just write by adding these two stuff. Right? So it's going to be 2 of H2S plus SO2 giving you 3 of sulfur. Right? Next step. Charge balancing. So at this side, no charge is there. At the other side also, there is no charge. So no need of adding H plus or OH minus. Right? This is a kind of acidic medium thing, right? So we know the H2S as well as SO2 both acidic, right? This is acidic, both acidic gases, right? So anyway, actually no need of using the H pluses as the charges are balanced both sides, right? So ultimate thing is to balance the hydrogens with the use of H2O. So you have 4 hydrogens here, 4 hydrogens, at this side no hydrogens, so 2 units of hydrogen difference, right? That can be provided by 1 H2O, sorry 4 units of hydrogen difference, right? 4 hydrogens are there, 0 hydrogens are there, so 4 units of hydrogen difference that can be provided by 2 H2O molecules, right? So those should be done at this side. So that is how we are supposed to balance the equation. Right now? Check it. The rocks balancing you straight balancing. Right? The half balancing at line would have balan no. Is it there? අපි එලෙක්ට්‍රෝකෙමිස්ට්‍රි ගැන කතා කරද්දී half balance එක තව කතා කරන්න. හරි මේ content එක කොහොම හරි කව වෙන්න ඕනේ. හරි half balance එකේ බලන්න. දැන් මේක පුළුවන් නිසා half balance එක පුළුවන් වෙයි. හරි එලෙක්ට්‍රෝකෙමිස්ට්‍රි කතා කරද්දී lesson එක එලෙක්ට්‍රෝකෙමිස්ට්‍රි lesson එක ඔක්කොලට මතක දීලා තියෙන මාර්ච් වල හරි ඒප්‍රිල් වල හරි. එතනදී අපි half balancing ගැන කතා කරන්න. හරිද? unit balance නම් මේ වැඩේට ඕනේ වෙයි. හරි? right නේද? question discussion වල සමහරවිට කතා කරන්න පුළුවන් වෙයි. half balance එක කියව ගන්න. half fraction balance එක right? Page number 7 වල දීලා ඉන්නේ. right? okay. හරිද? දැන් අපි යමු right? වෙන වැඩකට. right? මම අර කලින් කිව්වා ළමයි ඔයගොල්ලන්ට මේ අපේ රිලේෂන් ජාලි හතරක් තියෙනවා. right? With the chemical calculation stuff, right? 4 types of reactions are involved. Acid base, thermal decomposition, there was the precipitation and the redox. The redox balancing and redox reactions ලියා ගන්න ගැන තමයි කතා කරේ මේ. හරිද? තව පොඩ්ඩක් තියෙනවා how to select the redox reactions. Selection rules ටිකක් තියෙනවා කතා කරන්න. අපි next day කතා කරනවා. right? දැන් පොඩ්ඩක් මතක් කරගමු අනිත් reaction types ගැන. Mainly the precipitation type. precipitation ගැන පොඩ්ඩක් කතා කරමු. මොකද ඔයගොල්ලෝ chemical calculation question එකට වැඩියෙන් involve වෙන්නේ precipitation උයි redox උයි. thermal decomposition නම් අත්‍තරම මේ written paper එකට involve වෙන්නේ නැහැ. thermal decomposition involve වෙන්නේ MCQ එකට. thermal decomposition MCQ වල තියෙනවා. හරි? written එකට involve වෙන්නේ redox උයි precipitation තමයි main level. සමහරක් ලාට acid base උත් තියෙනවා. නැහැ නෙමෙයි තියෙනවා. හරි? ඔය reaction types තුන තමයි written එකට involve වෙන්නේ. වැඩියෙන්ම redox reactions and the precipitation. අපි මේ දෙක පොඩ්ඩක් මුලින්ම හොඳට polish කරන් ඉමු. මේ මම මේ දෙකේ කියලා දෙන්නේ. ඒක ඔයගොල්ලෝ හොඳට ගෙදර ගිහිල්ලා මේ දෙක හොඳට ready වෙලා ඉන්න. මොකද next day එකේ අපි තනිකරම කතා කරන්නේ calculations ගැන. අර ලොකු question එක, long question එක ගැන. හරි? ඒතකොට මේ reaction types දෙක හොඳට පාවිච්චි කරන්න පුළුවන් වෙන්න ඕනේ. redox reactions and the precipitation mainly. Precipitation පුළුවන් කියන්නේ acid base පුළුවන්. හරි? thermal decomposition වෙනම questions එක කතා කරමු. හරි? thermal decomposition ඉතින් ඔය වගේ MCQs වල තමයි. හරි? තග්ගල් precipitation reactions ගැන පොඩ්ඩක් මතක් කරගමුද? හරි? ඉතින් මේ ටික අපිට ඕන නිසා ඊළඟ කතාවට precipitation වල දැනගෙන ඉන්න ඕන කාරණා ටික මතක් කරලා දෙන්නම් ඔයාලට. හරි precipitation reactions. right. ඔයාලට precipitation වල කතාව. ready උද්ද බලාගෙන ඉන්න ළමයි මේ next day වැඩේට. right. So now we are into precipitation reactions. Right. Acid-base reactions as well as precipitation reactions are considered as ion replacement reactions. හරිද? දැන් අපි ඉන්නේ කියන page එකේද අපි ඉන්නේ page number 4 වලනේ. හරි? page number 3 වල තියෙන acid base, page number 4 වල තියෙන්නේ precipitation. හරිද? ඔය දෙකම ion replacement reactions. acid base එක ඉදර ගිහලා කියව ගන්න. ඒ උගන්නන්න දෙයක් නැහැ, චූටි කාලේ දන්න දෙයක්. හරි? acid base reactions as well as precipitation reactions are considered as ion replacement reactions. So the cation of one reagent will combine with the anion of the other reagent. Right? And the anion of the reagent 1 will combine with the cation of the reagent 2, like that. Right? These acid base as well as precipitation reactions are considered as ion replacement reactions. If you need an example like this, so if you are to react the barium chloride with, right, sodium sulfate, if they are saying some precipitation occurs here, right, what you need to do is, if they are saying some precipitation occurs here, question is precipitation වෙනවා. If they are saying that some precipitation is occurring there, right, what you need to do is just exchange the ions and write as products. Right? What are the ions here? Right? Exchange the ions. So what are the ions? Barium 2 plus and Cl minus. Here sodium plus and SO4 2 minus. Right? So these two guys connects and these two guys. Exchange the ions and write. That is barium sulfate and sodium chloride. That is how we are supposed to write the products. If they are saying a precipitation occurs, හරිද? ඔහොම අයන් දෙක මාරු කරලා ලියන්න. මෙයා කැටන් එක මෙයා නෑන් එක. මෙයාත් එක්ක මෙයා. හරිද? Then we have to decide out of these two salts which is going to be our precipitate. Now we have to decide. The question is කියනවා precipitate එක එනවා කියලා. කියන නිසා ion replace කරලා ලිව්වා. ඊට පස්සේ අපි decide කරන්න වෙනවා කවුද precipitate එක කියලා. Right? So it's a precipitate. So to decide that we need the knowledge of the precipitation table. To decide which is a precipitate, we need the knowledge of the precipitation table. Right? That table is given there. ඔන්න දිනන table එක. හරි? ඒක දැනගෙන ඉන්න ඕනේ. Right? The knowledge of the precipitation table is very important. I quickly go through the points there. ටක් ගාලා points එක කියන්න. Right? Precipitation table එකේ. First thing. First you should know, right, the ions, the type of ions which are never going to get precipitated. හරි? precipitate නැති කට්ටිය මුලින් දැනගෙන ඉන්න ඕනේ. Right? Group bonds, lithium is participating with a few of the precipitates. Other than lithium, the group bonds never involved in precipitations. So that this guy never involved in precipitation. No precipitation with group bonds. So this is not a precipitate. Right? Other than lithium, right? Always the group bonds are not going to precipitate. If your salt contains a group bond, no, it's not going to be a precipitate. Right? That's first thing. And second point, ammonium salts, NH4Cl, NH4 sulfate, NH4 sulfate, right? Ammonium phosphate, carbonates, ammonium salts, ammonium nitrate, never precipitates. If you see the NH4 thing appearing with a salt, no, it's not a precipitate. Right? What else? The ones which are not going to precipitate, right? Those are the stuff with the cations, which are not going to precipitate. When it comes to anions, with the stuff, right? Those are appearing in your tube, right? With anions, when it comes to anions, right? Nitrates, NO3 minus. Nitrites, NO2 minus. Acetates, C2CO minus. Manganetes, permanganates, KMNO4, MNO4 minus. Dichromates, Cr2O7, 2 minus. Right? Those guys never involved in precipitation. Right? When it comes to S block, which is indicated in your tute, right? When it comes to S block, sulfides, halides, the X minus, the halides, sulfides are also not going to precipitate. Regarding S block guys, right? With the S block cations, sulfides, halides are also not going to precipitate. The early anions are not going to precipitate with any of the cations. Right. So, that's why precipitation table is group 2 la group 2 cations, they are precipitation trends with oxalate ion, hydroxide ion, sulfate, sulfite, chromate, carbonate and phosphate ions. Those are the things you should remember. Group 2 oxalate කොහොමද precipitate වෙන්නේ, hydroxide කොහොමද precipitate වෙන්නේ, then sulfate, chromate, sulfite, carbonate and phosphates, how they are supposed to precipitate with the group 2 cations. That is the major stuff you should know. Right? So කොහොමද මේ trends ටික තියෙන්නේ? කොහොමද trends ටික තියෙන්නේ? Right? When it comes to oxalates, only the calcium and strontium. Calcium and strontium at the group 2 will get precipitated as oxalates, only those two. Right? But when it comes to hydroxides, right? The top two guys of the group 2, the beryllium and magnesium, will get precipitated as hydroxides. Right? When it comes to sulfates, the opposite trend appears. The bottom two will get precipitated as sulfates. For the hydroxides, the top two of group 2, beryllium and magnesium. For the sulfate, it is the bottom two, strontium and barium, will get precipitated as sulfates. When it comes to chromates, the same trend as sulfates will be followed by the chromates. SO42 minus, CrO42 minus. Same shape, same oxygen state, sulfur chromium, 2 minus charge. Normally chromates follows the trends of sulfates in precipitation. So, with chromates, the two guys at the bottom, strontium 2 plus and the barium 2 plus, will precipitate as chromates. Then you would observe that staircase kind of a relationship, right? When it comes to when it comes to sulfites, bottom 3. When it comes to carbonates, bottom 4. Calcium, strontium, right, at bottom 4. Right, magnesium, calcium, strontium, barium get precipitated. When it comes to phosphates, all the 5 at the group 2 get precipitated as phosphates. Right? That trend should be known. Trend එක විදිහට මතක තියන්න ඕනේ. ඔයාලට මතක තියන්න ලේසි විදිහට තමයි මම trend එක හදලා දීලා තියෙන්නේ. හරි? trend එක හරිය ලස්සනට මතක තියන්න ලේසි විදිහට set කරලා දීලා තියෙන්නේ. හරි? What else you should know? Right? You should specifically know about the trends of hydroxides, sulfates and halides. That's very needed, right? The trends of OH minus, precipitation trend, and sulfate and the halides should be known. Those are frequently asking, right, situations. Hydroxides are යට තියෙන points එක මේ කියන්නේ නේද? යට තියෙන points වල hydroxides highlight කරගෙන hydroxide trend එක. ඒක වැදගත්. What is the point? Yeah, with the hydroxides. It is a point number. Don't we have? Yeah, haven't written there. Hydroxide real is. Hydroxide. It's very important to come up with the hydroxides. Miss like. Few. Hydroxide point at the liagan. We are coherent yaking hydroxides liagan. Trends about the hydroxides. Hydroxide more than trends about the hydroxides. Hydroxide trend yaking liagan hydroxide, right? This is missing it. Okay. Magi only third point. Last reel I would have slide. Come on, Daddy. Okay. Hydroxide is only unknown. Okay. Printing will work. Hydroxides. Hydroxides is what trend? Tell me. Hydroxides. Lava S block ke di harima weak precipitation pattern ya to hydroxides will deal. Right? Very weak precipitation pattern in S block for the hydroxides. Only the beryllium and magnesium get precipitated as hydroxides in S block. But when it comes to P and D block metal salts, metal hydroxides, when it comes to P and D block metal hydroxides, all the P and D block metal cations get precipitated as hydroxides. S block එකේදී beryllium magnesium විතරයි hydroxide precipitate වෙන්නේ. හැබැයි P block එකේදී D block එකේදී හැම metal cation එකක්ම hydroxide precipitate කරනවා. Aluminium hydroxide precipitate, lead hydroxide precipitate, tin hydroxide precipitate, P block cations. D block ගන්න zinc hydroxide, chromium hydroxide, manganese hydroxide, iron Fe2+, both hydroxides, zinc hydroxide, then nickel, yeah, all the D block cations get precipitated as hydroxides. So S block එකේ තමයි weak precipitation pattern එකක් තියෙන්නේ. Beryllium magnesium විතරයි precipitate වෙන්නේ hydroxides එකට. හැබැයි P and D block metal cations හැමෝම hydroxides precipitate වෙනවා. Precipitation trend is very strong for hydroxide when it comes to P and D blocks metal cations. දැනගන්න ඕන hydroxide වැදගත් case එකක්. විතරම හින්න දාන්න. ඊට පස්සේ it comes sulfates, very important sulfates. Very important sulfates. Only 3 cations are able to precipitate as sulfates. Only 3. Full syllabus එකේ 3 දෙනයි. Only 3 metal cations are able to precipitate as sulfates. Definitely you should know this. Highlight කරලා තියාගන්න. 3 දෙනයි කවුද? There are 2 at the S block. Strontium, barium. S block එකේ යටම දෙන්නෙක් ඉන්නවා. What is the other one? That is a lead. Only 3 cations are able to get precipitated as sulfates. Lead, strontium and barium. Those are white PPTs. Strontium, barium and lead. Only those 3 are available as sulfate precipitates in all the A-level syllabus. Alright? Sulfate la 3 දෙනා ඉන්නේ. හොඳට highlight කරගන්න sulfate 1 point sulfate එක තියෙන්නේ. 1 2 3 4 5 5th point එක හොඳට highlight කරගන්න. 5th point. හරි? sulfate point එක ඊට පස්සේ light අන්තිම point එක highlight කරගන්න ඕන hydroxide එක. හරි? ඒක වැදගත් case එක. ඊට පස්සේ highlight කරගන්න මොකද? halide case එක. Halides. What about halides? In S block, no halide will get precipitated. No halide precipitation with S block. S block cations never get precipitated as halide. Never get precipitated as halides. S block cations. But we have 4 such halide precipitates. 4යි තියෙන්නේ. මුළු syllabus එකේ halide precipitation 4යි තියෙන්නේ. Sulfate precipitate මුළු syllabus එකෙන් 3යි තියෙන්නේ. halide ල 4යි ඉන්නේ. What are the 4? Actually 3 guys are appearing with the group penalty group 1. 3 guys are appearing with the group penalty group 1. What are those 3? Silver halide, lead halide and the mercury halide. Mercury +1 halide, HgCl. One can write it as Hg2Cl2. Anyway, +1 oxygen state there. Right? Mercury halide, PbCl2, lead halide, PbCl2, PbBr2, PbI2, any halide with the Pb2+. And the silver halides, AgCl, AgBr, AgI. Those 3, and very special thing is they are coming from the CuI. Copper +2 is not going to precipitate as Cu2i. Sorry, copper +1 is not going to get precipitated as a halide. but plus 1. There is no precipitate as CuI2. CuI2 के precipitate नहीं होंगे. CuI तमाई दिए. Right, coppers plus 1 oxygen state will come up as a halide precipitate. So, ඔය හතර තමයි දින්නේ. මොකද Pb2 plus Ag plus mercury plus and the copper plus. The copper plus කතාව ලොකු කතාවක් නෙවෙයි. කතා කරනවා අපි next week එකේ. හරි. So, ඔය තමයි precipitate වෙන කට්ටිය. කිව්වත් එක තමයි ඔයා precipitation එකක් select කරගන්නේ. හරි. ඕකෙත් ස්පෙෂල්ම කතාවක් තියෙනවා. තව ස්පෙෂල් දෙයක් තියෙනවා ඔයගොල්ලගේ bold කළා. And even at the box at the bottom, very special story is said. What is that? Out of those precipitates we had discussed, right? We have some special precipitates which are not going to dissolve even in dill acids. ළමයි සාමාන්‍යයෙන් precipitate එකක් dill acid එකක් දාපු ගමන් dissolve වෙනවා. Normally a precipitate will dissolve when you are to add a dill acid. Normally precipitate dissolve in dill acid එකක් දාපුවා. හැබැයි we have two special kind of precipitates which are not going to dissolve in dill acids. Those are the precipitates formed by sulfate anions as well as halide anions. Those are referred to as precipitates coming from strong acid anions. Precipitates coming from strong acid anions. Those are only available. Precipitates from the halide anions and precipitates coming from the sulfate anions. Referred to as precipitates coming from the strong acid anions. Those won't dissolve in dill acids. Other guys will dissolve. අර ඔක තමයි රියල් තියෙන බලන්න. අර within brackets තියෙන. Sorry මේ at the bottom of the page you have a box and it is said precipitates with strong acid anions. Only two kinds are available ළමයි. ಜಾති දෙකයි තියෙන්නේ. Sulfates and halides will not dissolve in dill acids. While precipitates with weak acid anions will dissolve in dill acids. ඕක මාර වැදගත් තා questions වලට යද්දි බලමු. මාර වැදගත් කේස් එකක්. උඹලට තීරණ වශයෙන් කියනකො වැදගත්කම. දැන් හිතන්න මෙහෙම. Just think. Let's discuss think of this thing. දැන් හිතන්න right? You have a solution. 25 milliliters of solution let's say. Right? And you have SO3 2 minus and SO4 2 minus. You are supposed to come up with the concentration of these two guys. ඔයාලා මේකේ තියෙන මේ දෙන්නේ concentration හොයාගන්න ඕනේ. හරිද? Then finding out the concentration of these two guys means coming up with the number of moles of these two guys. මේ xy moles දෙක හොයාගත්තා නම් හරිනේ. As you know the volume, you can come up with the concentration. Right? එතකොට මම මේ කතා කරන්න යන්නේ අර dill acid වල දී වෙන කතාව. මොකද්ද ඒකේ importance එක? Right? So you can come up with like this. You can put some to this one. You can put some excess of barium chloride. You can put some excess of barium chloride. So what will happen, Laman? Tell me what will happen. Right? So you have the barium 2 plus ion here as well as the Cl minus ion here with the barium chloride, right? So Cl minus won't get precipitated. Why? You don't have any positive ions to combine with. The positive ion එකෙන් නැත්නම් combine වෙන්නේ උට බුක් කරන්න දෙයක් නැහැ. Positive එකකින් ඉන්නේ බයි combine වෙන්න precipitate එකක් විදියට. Precipitate is kind of a compound, ionic compound. Should have positive ion, positive ion නැහැ කරන්න බෑ නේද? But we know the Ba2 plus will get precipitated with sulfite as well as sulfates. Both the sulfites as well as sulfates will precipitate the Ba2 plus, right? So what will happen? If you put this thing, you will come up with a precipitate containing barium sulfite as well as barium sulfate. Right නේද? ඔබ දැම්මොත් ඔයාලට precipitate එක දෙනවා මේ දෙන්නගේ. What are the amounts? Definitely as you are with only x moles of sulfite here, this amount is going to be x moles තමයි. Right නේද? Right? This x moles, right? So as you are not adding the sulfites from top, or you are not going to release the sulfites here. Sulfites අඩු කරන්නෙත් නැහැ, එකතු කරන්නෙත් නැහැනේ. So the same amount of sulfites here should appear here, right? So x moles. So this is y moles. Right? See how we are supposed to use that dissolving in dill acids in problems only. Right? So to solve for two unknowns we need two equations. So solve for two unknowns, we need two equations. If we are to solve these two things, we can come up with the constraint of these things, right? Okay. So the first equation can be taken from here by the mass of this one. If the mass of this one is m1, right? You can take the first equation from here, right? So this guy's molecular weight is 2 to the 3. Sorry, 2 to the 3 for this one. This one, it is 270. So we can write the 270 into x, that guy's weight, plus this guy's weight, that is 233 into y, this guy's weight, g mole minus 1 value into mole value. Weight is equal to m1. That is how we are supposed to come up with the first equation. Right? Let's use that idea, dissolving in nil acids, to come up with the second equation. How come? If you are to put some nil acid to this one, if you are to put some nil acid to this one, it could be from nil HCl, right? So what will happen? So Lamai, as this guy is a precipitate without a strong acid anion, this will dissolve with nil plus, right? As this is a precipitate with a strong acid anion, sulfate, it won't dissolve, right? So what will happen? So you will come up with a situation where the barium sulfate will only appear as the precipitate, while the barium sulfide will dissolve. Right? Nowadays, you know, the sulfide will combine with the H pluses to form the H2SO3 and the SO2 will release. Those things you know, right? Basically, these two guys will combine, right? That such kind of thing appears, right? Anyway, it is not that much needed, right? So, anyway, barium sulfide will dissolve, while only the barium sulfate will stand as a precipitate. So, bimoles of barium sulfate will stand as the precipitate without dissolving, while barium sulfite dissolves in DLH plus as it's a precipitate without a strong acid anion. This stands. So if you know the mass here, if you are able to calculate the mass here with the precipitate, let's say it is M2, then you can come up with the second equation there, mass for the mass of barium sulfate. So that is going to be M2 into its molar weight. Its molar weight is 2 to 3, right? If Y moles are there, that is the mass of the barium sulfate. Y moles and 2 to 3 is the G mole minus 1 value. That is equal to M2. So by solving these two equations, you can solve for X and Y, right? So there we use that theory. When it comes to precipitates, ones with strong acid anions won't get dissolved with DL acids, but the precipitates without strong acid anions will get dissolved, right? Okay, so that is the application of that point, right? Solving the 1 and 2 will give you the X and Y values. Equation 1 and 2 will give the X and Y values. හරි? ඉතින් ඔකත් අපිට use වෙයි අපේ calculations වලදී. right නේ? හරි. ඉතින් ඔය තමයි precipitation වල කතාව. right? දැන් හිතනවා දැන් ඔයගොල්ලන්ට වැඩි set ඇති කියලා. precipitation table එකෙන් decide කරන්න පුළුවන් කවුද precipitate වෙන්නේ කියලා. right? හරි. okay. ඊළඟ අපි අදට මෙතනින් නවතිමු. right? එතකොට අපේ අද session ඔයගොල්ලගේ Wednesday session එකේ වෙන්නේ අර මම කිව්වා වගේ MCQs ටික කතා කරන එකයි. Wednesday night session එකේ MCQs ටික කතා කරන එකයි. ඊට පස්සේ අර ionic bond, metallic bond එකයි secondary reactions කතා කරන එක තමයි එතනදී වෙන්නේ. right? afternoon session එකේ මේ Wednesday night session එකේදී. ඊට පස්සේ next week අපි තනිකරම කතා කරන්නේ calculations ගැන. right? තනිකරම past week calculations වලට යනවා. ඉතින් මේ අද කතා කරපු calculations එක හොඳට බලාගෙන ඉන්න. right? tutor පොඩක් කියවගෙන ඉන්න. ඒතර අපිට ලේසියෙන් ඒ වැඩ ටිකට යන්න පුළුවන්. right නේ? සහ අනිත් එක මේ group එකට add වෙච්ච නැති කට්ටිය මට message එකක් හරි දාන්න. හරි මේ තොර group එකට add කරන්න revision group එකට. ඒකේ තමයි videos share වෙන්නේ ඉස්සරහට. වීඩියෝස් මොන හරි තියෙනවනම් ඔක්කොම ෂෙයා වෙන්න එතන. ඒක නිසා මේ ඒක ටැග් වෙන්න. හරි මට මෙසේජ් එකක් දාන්න. මට හරි නැත්තම් මේක පිටිපස්සින් නම් එකකට දාන්න. 2026 රිවිෂන් කියලා ලියලා දාන්න. හරි. නැත්තම් දන්නේ නැහැ නේ කොහොමද කරයිද දන්නේ ඔයගොල්ලෝ. හරි. ඒක දාලා කරන්න. හරි එහෙනම් අද නවතිමු. Goodbye then. See you next week.